But today we're doing 3 topics, and I want you to listen very carefully, because we are going to be giving your teachers a test, all right, for you guys to write on these 3 topics. That test will be a practice test. It will count for us because we want those results, but it'll be a great opportunity for you to practice before you write your test, which the department is going to give you, your schools are going to give you. Okay, all right. So the revision today, then a test that we're going to give to your teachers, and then the test at the end of the term. Okay. We're going to dive straight in. Just before we do, I'm really hoping, and Ruth and I are really hoping, that you guys are using the workbooks that we've provided. Are you using them? Okay, siyajabula. Okay. Siyajabula ukunibona la namhlanje namkhelekile. Okay. So, guys, the first topic that we're going to be talking about is sequences and series. We may not finish all of these questions today. It might be that we don't do all of them, because we do want to make sure that we do all the topics. Okay. We want to involve you as much as we can. I don't want to do all the talking today. So Ruth is going to walk around with the microphone, okay, and she's going to we've got some learners joining us from Belfast Academy up in Mpumalanga, so we're very excited about that. The 24 learners, welcome to them. All right, guys, I'm going to ask Ruth to walk around. I'm going to ask you to put your hand up, and the first question I just want to ask someone, just so they can explain to the learners in the room, what have you got the microphone here? Yeah. What how we know when we've got an arithmetic sequence. Okay, what is an arithmetic sequence? If you're telling your friend, here Nelia, what is an arithmetic sequence? Maybe you can just put your hand up if you know. What is an arithmetic sequence? Okay, don't be shy, guys. Don't be shy. Ruth has even got a few small sweets. I'm a sweetie, I'm a nani. Okay, there we go. Take the microphone and talk to us. Yeah. Okay, who have we got here? Okay, there's a bit of collaboration going on. Is the microphone on first? No. Sorry. Okay, we'll get there. Yeah, testing. Okay, who are we listening to here? Okay, constant common difference. So we're okay with that. All right. For example, 2, 5, 8. What's the common difference here? You can all just say it out loud. 3. Okay, great. Who can tell us, how do we know when we've got a geometric sequence? What's the scene there? Okay, let's just put a hand up. Okay, Ruth's going to get very fit today. She's going to run maybe 10 kilometers. Common ratio. So, guys, for example, 2, 6. If it's 2 and 6, what must the next number be if these are in geometric sequence? Hey, my man. No, not 12. 18, guys, what are we multiplying by to get from 2 to 6? By 3. What's 6 times 3? 18. Hala. Okay, and the quadratic sequence, we've got a common second difference. Okay, on this sheet, and I know it's not in color, we would love to print it in color for you, but on this sheet, in blue, these are the formulas that you will get given in your tests, in your exams. Now, I want to just talk very quickly, and maybe you want to just put stars next to them. Maybe you want to put a big star. These formulas do not get given to you for the quadratic sequence. Okay, there are 3 of them. The first one says that if we want to find A, we take our second difference and we divide it by 2. The next one says that if we want to find B, now we know what A is, we take 3 lots of A plus B, and that gives us the first term of the first differences. And then the last one is that if we want to find C, remember we now know A, we know B, and the way we're going to find C is that A plus B plus C is the first term of the original sequence. Okay, we're going to ask, and some of you have had some time to do this while you waited, so we're going to ask someone to tell us how to do these questions. Now, for me, the first question you need to ask yourself in sequences and series, Is it a term or is it a sequence? Are we kind of in this column, okay, or are we in this column? So is it a term or is it a sum? And then the next thing you've got to ask yourself is, which type is it? Is it arithmetic? Is it geometric? Norma, is it quadratic? Okay, right, let's go. I want someone to answer this question for us. Okay, Ruth's going to greet you by name so we know who you are. And we want loads of different learners from different schools, guys. You need to understand, to bring learners here, especially, ayadula impela. Okay, namhlanje. The buses, the taxis, the food, everything. So all we want for you to, the way we want you to say thank you is that you are concentrating and you're working hard. Okay, right. Okay, you can say your own name. If Ruth's struggling with your name, just hold the microphone, talk nice and clearly. Welcome. Thank you. It's a term formula, and what formula must I use? Arithmetic. Okay, I'm going to write it down, guys. Okay, now tell me what. What did you? How am I going to work it out? Okay, I'm going to do that in my head. Yeah. 4. Well done. What did you get for your final answer? Halala. Okay, that's all. Okay. Okay. All right. I'm looking for someone to help us with B. We want T12. Hi. Everybody come along. Okay, cool. Okay, excellent. I've just lost my whole thing here. Okay, geometric. Okay, and what? So I'm going to write the formula down. Geometric term formula A R to the n minus 1. What is T12 going to be? In bracket 1/2. Okay, 12 minus 1, 11. Okay, hala. What did you, guys, remember how we work out R? R is any term divided by the term before it. For example, it's T4 divided by T3. It's a half. It's 512 divided by 1024. It's a half. It's always a half. What was your final answer? 1. Hala. Okay. All right. Guys, if you disagree with the answer, because I haven't checked that on a calculator, then just say, okay. All right. Next up. This time, S30. S30. Someone. Excellent. What formula must I use? The sum of arithmetic. Okay, I'll write it down. Right. Magic. Then our n is 80. Yeah. And divided by 2. So 2 divided by 3. Yeah. Plus 80 minus 1 times 1,5. 1,5, good. 1,5 is the common difference. What was your final answer? Well done. Okay, I think it's right. Guys, if it's not right, you must say, I corona. Okay, all right. Guys, this, I don't know if you've noticed, but every time I get to an answer, I underline it. Okay, it's not a very good line, it's not very straight, but it helps your teacher see where is your final answer. And you want to be proud of your final answer, so get into the habit of underlining your final answer. Right, this one, sum to infinity. What formula are we going to use? And what's the formula say? Well done. All right. What did you get for your final answer? Well done. Hala, hala. All right. Okay. Good. Excellent. Guys, Pinduli Kasi. We're going to leave number E. I'm looking for someone to tell us how to do F. All right. And I'd like you to try and explain what you're going to do, what you did. All right. Because now there's maybe some people who, my sister Ruth, Manje, she's seeing this and she says, Manje, yasaba, hinile. Okay. Ruth doesn't know what this is. Okay. Tell us what we're going to do here. First three terms, okay? What will the first three terms be? And what must I write in between here? Sorry? Must I put semicolons or must I put plus? Plus. Guys, what does this symbol mean? It means sum. It means add up. Okay, so now, which formula are we going to use? Sum of arithmetic, okay? I'm going to write it down for you. Right, now, the next question I want to ask you is how many terms are we going to have here? 13. Okay, can you tell me how you worked it out? You are right. Yeah. Well done. Hala, hala. Guys, just bus off. If it doesn't start at 1, then there's a little quick trick for the number of terms. We're going to take the top number minus the bottom number, okay, plus 1. So in this case, 15 minus 3, that's 12, plus 1 is 13. Okay, now we can put our things into our formula here. You tell me S13 is going to be what? Yeah. Okay, I'm going to do that in my head. 22. Well then, yeah. 12 times 3. And your final answer? 327. 377, sorry, 377. Hala, hala. Okay, all right. Now, guys, let's now look at the next one. The next one is a little bit different because these questions, everything in question 1, I would describe as either knowledge or routine. In other words, these are the quite easy questions. Okay, maybe F's a little bit harder. Now this question here, I would describe as a more complex question. This is a complex question. Okay, right, who can tell us how are we going to do it? We now want to find K. It's running, she's going to be tired tonight. Uzolala kahle namhlanje. No, not namhlanje. Excellent. Okay. Okay. Is that where you started or did you do something else first? First 3 terms. Okay, that's great. This is the right formula, I think, but let's just write down 3 terms to see what we're dealing with. 3 terms is enough for us to know. Yeah. Okay, I'm going to put that in brackets just to show us that's the first term. And the second term? Okay, and the third term? Okay, great. Now, what must I put between these brackets? Times or plus? Plus. Plus. Remember this means sum. Okay, all right. And so what sort of sequence is this? Is it arithmetic or is it geometric? Arithmetic. What is D? D is K. D is the difference between this term and that term. If we take this whole term, all this yellow stuff, and we subtract all this pink stuff, we get K. All right. Okay, now tell me what you put in your formula. Is what? No, that's your final answer. But what did you use in your formula for N? Yeah, you're giving me the final answer. That's cool. Oh, sorry, guys. Sorry. Okay, where am I? Okay. Okay. Sorry. 1,310 is the answer. There it is. Sorry. Okay, equals 20 over 2. Halala. Guys, are we okay that there are 20 terms? 23 minus 4 plus 1. Okay. All right. 23 minus 4 plus 1 equals 20. All right. Carry on. What's A? Okay. So 19. Okay. Excellent. How many variables in this equation? Any Lord one, just one. And when we've got an equation with just one variable, we can solve it. We must be good enough to solve it. Okay, carry on. Tell me what you're going to do next. And I'm going to draw a little picture here. And if you've watched even one of my videos, you should not be surprised. Okay, this is a scale. And when we solve an equation, it's like a scale. And whatever we do to the one side, we must do to the other side. Okay, so what is our what are we going to do here now? Yeah. So I'm seeing 2K here. Sorry. Okay, 8K. All right, minus 4 plus 19K. So what does it come to? 27K minus 4. Guys, if I leave something out, you must shout straight away. Say, Paul, stop. Yeah. Okay. All right. What are you going to do next? You're going to divide by 10 on both sides. Guys, you can multiply this in here, and it's not wrong. But maybe it's actually easier to divide by 10 on both sides. You're going to get the same answer. What must we do next to both sides to make this a bit better? Add 4. 135 is 27K. How do you get K? Divide both sides by 27. I think we should give a round of applause. Okay.
Are you recording?
I am recording. Yeah. I'm recording. Okay. All right. This one here, we're going to come back to this. No, we don't need to come back to it because we've learned what we need to know for this. Okay. All right. Lots of people joining the meeting, which is wonderful to see. All right. We're on, I don't know if I numbered the pages. I did. We're on page 3. We're on number 3. All right. Let's look for an answer to this question. And guys, I am going to, I'm soon going to ask Ruth to, if you would like to just sort of go outside with Ruth, maybe your teachers talk to you and to be videoed, that's fine. And then I'm going to ask Ayanda to grab the microphone. I'm looking for Ayanda. Well, when we find there's Ayanda there. Yeah, is anyone ready to go now, guys? You can just put your hand up. You'll just miss one or 2 minutes. Okay, there's someone. Yeah, thanks. Is that Langa? Okay. All right. Okay. All right. So Ayanda's going to come with the microphone. I'm looking for an answer to this question, guys. Okay. All right. And maybe others, if you can think, Am I brave enough to go outside and speak to Ruth? Ruth, she's very scary. Yeah. Okay. All right, guys, anyone? I'm looking for an answer. Ayanda's got the microphone. She's looking to come and get an answer from someone for this question. Okay, and Boo's coming now. Boo will be outside just now, no sweat. All right. Okay, guys, does no one know how to do this question? What sort of sequence is this? Put your hand up. It's either arithmetic or it's geometric or it's quadratic. It's geometric. Okay. Put your hand up if you can help us even make a start. You don't have to be able to answer the whole question. If you've got some idea of where to start. All right. Ayanda seems to have found someone. She is walking with purpose to someone. There we go. Okay. All right. Tell us what this question's about. Okay, good. It's geometric. Have you worked out what R is? It's 11 over 10. Well done. 11 over 10, guys, is 1, 1. Okay, so we know what R is. Maybe some of you are not sure about this word, okay? And this word means to be bigger than 10 million. So this thing is growing, okay? It's actually an exponential graph, okay? Because this power, this base here is 1, 1. It's an exponential graph that's going to be very steep uphill, okay? All right, now let's have a look. What do we know? Which formula are we going to use? Are we going to use the term formula or the sum formula? The term formula, it tells us here, term, yeah. Okay, I'm just going to put this in here. All right, so now, what we're going to do is we're going to make this equal to 10 million. And what must I put on the right-hand side here? Yeah. One comma 1, yeah. To the n minus 1. How many variables in that equation? Any order, just one. Okay. Now, what are you going to do to both sides to improve this equation? Divide both sides by 10. This will be 1 million. I can even do that in my head. 10 million divided by 10 must be 1 million. Now we've got 1 comma 1 to the n minus 1. Okay. I'm just looking what Ruth needs. What? In my bucky? Yeah. In my bucky. Okay. Yeah. Okay. On the back seat, there's like a leather pouch. Okay. All right. Okay. And now, what are we going to do? How are we going to solve an equation when the variable is in the exponent? Log. So can you tell me what are we going to write? Yeah. Well done. Okay, and then obviously if we want to find n, we're going to add 1. What was your final answer for n?
Final answer for n was n must be
146. Okay, now guys, I'm going to just show you this, and again, if you've watched the videos, you would have seen, but this sequence, I'm going to show you how we can check that answer in Excel. Okay, all right. So Excel's very, very powerful. So here we go. All right. So the first term was 10. The next one is 10, is that one times by 1 comma 1. Okay, there it is. Now, if I copy this down, it will just times. Okay. Now, what I'm going to do now is I'm going to write these amounts as money. Okay. The only reason I'm doing that is it's easier to see the decimals. Okay. So there is a million. The 129th term is 1,987,000. Okay. Here is the 145th term, guys. It's not bigger than a million. The answer that our friend got there was 145 comma something. Okay. So the 145th term is less than 10 million. There is the 146th term. It's bigger than 10 million. Hala. Okay, right. Let's have a look. Okay, now here's a question. We've got some information here. We are told that it's arithmetic. Who can tell me how are we going to find the first three terms of this thing? Hala. Yes, I'm so proud. Okay, we're going to use simultaneous equations, guys, because if we know A and we know D, are we okay that if we know A and we know D, we can write down the whole sequence? Yes? Okay, so that's what we want to do. We want to try to find A and D. Okay, now tell me what your first equation is going to be if you know that term 9 is 13. Well done. Sure, 13 equals A plus 8D. All right, now that there, I'm highlighting that blue. Okay, and the reason I'm highlighting that blue is that that equation came from that piece of information, from the blue piece of information. Nancy and Kinga, we have a problem, okay? Maybe the learners in Belfast don't understand Nancy and Kinga. Maybe in Belfast they're saying, ons het 'n probleem, okay? We have a problem. The problem we've got is how many variables are in this equation? 2, all right? 2 is a problem. We can't solve if we've got 2 variables. We need another equation. Give us your next equation.
A.
No, careful. It's not going to be A plus 9D. Just watch very carefully. This is not T10. This is S10. Okay. So I'm going to write the formula down here. And let's see if we can work out what to put in this formula. All right, 60 will be what? 5, 10 over 2, huh? 5, open brackets, 2A plus, how many D? 9D. Hala. Okay. So notice, guys, there's 2 very different looking equations here. The blue one is from the term, the yellow one is from the sum. Each of them has got 2 variables in. Okay, now I'm going to number these equations. I'm going to call this one number 1, and I'm going to call this one number 2. Which equation do you think it will be the easiest to get one variable, to isolate one of the variables on its own? Equation 1, and you're absolutely right. And which variable will be easier to isolate, the A or the D? A. What is A the same as? Well done, hala. Okay, now what we're going to do, we are going to take that value for A, all right? And we are going to put it into this equation over here. Okay, so let's go. We're going to go 60 equals 5. 2 lots of 13 minus 8D. If there are teachers in the room, if you wouldn't mind seeing if there are other learners of yours that are happy to talk to Ruth quickly on camera. Okay. All right. How many variables are there now? 1. Okay. All right. And let's see if you can, if you're happy to, maybe you can keep talking me through it. Okay. Alanga and Ruth are back. So if there's another learner, you can just put your hand up. This is to go outside to talk to Ruth on camera. Just put your hand up if you're happy to do that. In fact, you can even just stand up and go, yeah. Okay, that's great. All right, tell me what we're going to do next here. What should we do next? Has someone still got the microphone? It doesn't matter if that learner goes now. They can go also. They can go and wait outside. Okay. Okay. Are you taking the microphone? Okay. All right. I'll carry on here. Thank you very much. Well done. Guys, if we divide by 5, we get 12. Inside here, we're going to get 26. minus 16D plus 9D. All right. Sorry, I don't know what I've done here. This is 12 equals. Sorry. Okay. Now, I'm going to subtract 26 from both sides. Negative 14. What's inside? What's minus 16D plus 9D? Negative 7D. What must I do to both sides to get D? Divide by negative 7. Well, remember when we divide a negative by a negative? At the moment, I'm doing lots of grade 8 videos, and we're doing integers, and you probably think, I remember that. Yeah, but when we divide a negative by a negative, we get a positive. Now we know what D is, we must find A. Here's an equation that tells us what A is. A is 13 minus 8 times 2. A is 13 minus 8 times 2. A is actually going to be 13 minus 16. A is going to be minus 3. All right, and guys, if A is minus 3 and D is 2, what's the next term? Minus 1. And what's the next term? Plus 1. Okay, and what I want to show you, plus 1, yeah. Okay, I want to show this to you again on here, right? So I'm just going to get a new spreadsheet here. I'm going to make it nice and big. So minus 3, minus 1, 1. I can drag this down, all right? And we can have a look here. Okay, now if we go back to the question, remember what the question said. The question said T9 is 13 and the sum of 10 terms is 60. Let's check this, guys. If we look for T9, there's T9, it's 13. If I highlight the first 10 terms, what you might see over here, I don't know if you can see down there where my mouse is, it says the sum is 4. If I highlight the first 10 terms, what does it say the sum is? 60. Are we right? Halala, we're definitely right. Okay, right. I'm going to leave one or two questions out, all right, because I want to look at some slightly different questions. I want us to look at question 7 now. Okay? So, and there are 3 parts to question 7. I want someone to tell me what equation can I form, because this does not use a formula. And often people try and use a formula for this question and it becomes a problem. What am I going to do here if these are consecutive? Okay, I think we've got a hand up there. I am looking for hands. Okay, there's a hand there. Thank you. Yeah, great. Amashle, thanks, Amashle. Okay. Well done. Hala, that's very nice. And that's nice to set out your working first up. Yeah. 4p plus 2. When you're saying into, you're saying brackets, eh? Great, thank you. Yes. Hala. Guys, we've got one equation with one variable. Carry on. Yeah.
5p plus 3, negative 4p.
Okay, great.
We're gonna subtract like
Yeah.
we're gonna end up with 2p minus 1.
Yeah.
It's equal to p plus 1.
Great.
Then we're gonna subtract by p both sides.
Okay.
We're gonna end up with p is equal to 2.
P equals 2. Well done. Okay. Let's check it, guys. I'm sure it's right because I didn't spot any errors. But let's check it. If P is 2, this number here, 2 times 2 is 4 plus 3. This number is 7. If P is 2, this number is 10. And if P is 2, what should the next number be if this is arithmetic? It should be 13. And 5 times 2, 10 plus 3, 13. Yes, hala, hala. Does it make sense? Does it make sense? Okay, all right. So now, very nicely answered. Who can tell us now how to do the next one? This very similar question. Okay, there we go. We've got to learn. I think it's Amashlubi. Is it Amashlubi? No, in Genova.
Good morning.
Morning. Hi. T2 over T1 is T3 over T2. Well done. Okay, great. Yes. Okay, I'm hoping that all of you know that that's okay. If you've got two fractions that are equal, the top of the left one times the bottom of the right one is equal to the top of the right one times the bottom of the left one, okay?
3p squared plus 24p plus p plus 8.
Okay, 3p squared plus 24p plus p plus 8. Okay, so that's basically just that times that, yes. And this side? 4p squared plus 8p plus another 8p plus 16. Okay? Okay? I'm going to leave that line. Go to your next line if you don't mind. Yes.
0 plus 4p squared. P squared plus minus 9p plus 8.
Okay, minus 9p plus 8. Okay, all right. Guys, that word transpose, I know lots of your teachers use it. Okay, I prefer subtract it from both sides or divide both sides. Okay, because, yeah, so I'll just explain why, guys. If we've got p minus 2 equals 7, so lots of teachers say we take the 2 to the other side and we change the sign. Okay, we transpose it. My concern now, when we've got 3p equals 7, when we take the 3 to the other side, we don't change the sign. So for me, mathematically, it's better to understand we're going to add 2 to both sides. Normally, we're going to divide both sides by 3. Okay, all right. What did you get as your final answers? Yeah. P equals 8 or 1. Well done. Very nice. Okay. Right. Very well answered. Okay, now let's just again, like we did last time, I'm going to check. Guys, if P is 8, I get 25, I get 16 plus 4, I get 20, and I get 8 plus 8, I get 16. If you take this divided by that, you get 4 over 5, and if you take that divided by that, you get 4 over 5, or 0.8 if you need to use a calculator. It's definitely right. The other option, if P is 1, we get 4 from our first term. We get 6. And 6 divided by 4 is 1.5. If you multiply 6 by 1.5, you get 9. And if P is 1, 9 is our third term. Both answers work. Okay. All right. Then the next one. Okay. What are we going to do here? Now we are told that this is a quadratic progression. Quadratic progression. Looking for an answer, guys, in the room.
Yes.
Yeah. Okay, so you've taken the bracket straight out, that's fine. That's our first difference. Yeah, and then I'm going to put a semicolon. What will the next one be? Okay, well done. Guys, I hope you're okay with this. This learner is distributing that bracket straight away. So in other words, they're going minus 2p minus minus 1. Okay, 100%. For p plus 2. Okay, great. P and then? Yeah, and then? P plus 2, great. Now guys, what is this line? Tell us, what is this line over here? What are these? No, this line. This line is our second differences. And what do we know about our second differences if we're dealing with a quadratic? Okay, they must be equal. So what equation can you make for us now? Oh, sorry. Guys, these are not the second differences. My apologies. You said first differences, and I tried to correct you, and I was wrong. What confused me is that we were on the second row. The only reason we're on the second row is we were tidying up, weren't we? These are the first differences. Carry on, sorry. Yeah. Yeah.
Thank you.
Sorry. Yeah. P plus 2, yeah. P plus 2 minus 2p, yeah. Plus 1, huh? Okay, and these are the second differences, but I'm going to put a big equal sign there because the second differences are equal if we've got a quadratic equation. Carry on. Yeah. Plus 3. Okay, carry on. P plus P, 2p. Well done. And so final answer, P is 2. Well done. Okay, excellent. Right. All right, guys. The terms actually work out to, if P is 2, the first term is 1. The next one is 3. The next one is 6. And the next one is 10. Those
Yeah.
are the quadratic sequence. Okay. All right, guys, if you're joining online, please just mute your microphones because I am hearing and it's I'm just going to mute everyone. Sorry. I'm delighted to see so many people in the room. All
Can't hear
right.
you. Hello.
Okay, so we've got one or two people struggling to hear, but yeah. Guys, I'm going to mute everyone just because okay. All right. So now there's a couple more questions here. We're not going to do all of them. I want us to try and do number 9. Okay. And I want to see if we've got anyone in the room who can who can tell us how to do this question? Okay, it's a little bit tricky because, right, yeah, let's just see. Okay, I'm going to do this one together, all right? A tree grows 1,2 meters in its first year. Now, thereafter it grows by 20% of that amount. So in the next year, it will grow by 20%. 20%, guys, is 0,2, that's 20% of 1,2. That's how much it will grow in year number 2. In year number 3, it's going to grow by 20% of this amount. So we're going to multiply with another 0,2. And what sort of sequence have we got here? It's geometric, okay? It's definitely geometric. What is R? R is 0,2. Now, will this series converge? And how do we know whether it converges or not? You can just put your hand up and maybe you can just quickly tell us. How do we know when a series converges, a geometric series? If you know, put your hand up. Ayanda's looking for you with a microphone. She's also looking to give you a sweet. Over here, Ayanda down on this row. Over here, yeah, just put your hand nice and high so Ayanda can see. There we go. In this row you're coming to now. Okay, will it converge? Yeah.
Ish. Let me ask about the number 7.
Okay. I'm hearing people asking about number 7. I'm not saying number 7.
No.
Okay. Done number 7. Yeah. Maybe, guys. Maybe if you've got a question, maybe you can just ask in the chat, and then I will monitor the chat, and then we can try to answer your question. Okay. All right.
Can we
So
back to number 7?
absolutely. R is
Number
between
7.
-1 and.
Didn't understand number 7.
Didn't understand number 7. Okay, I will go back to number 7. I'm going to finish this question first, and then I'll go back to number 7 briefly. Okay. Right.
It's number 7. Number 7.
Yeah, I've heard you say number 7. Yeah. Okay.
Number 7.
Right.
Number 7.
Okay.
We lost. Yeah, we lost number 7.
Okay. Right. So, guys,
What did you want?
this is not the height of the tree. This is the growth of the tree. So to get the height of the tree, all right, we need to add up all the growth. Okay, and this is where we're going to use our sum to infinity formula. We're going to take A over 1 minus R. All right, so we're going to take 1,2 over 0,8. 0,8. Okay, and we get, maybe we can just get I can see if I can find a calculator over here. Right, my calculator's gone miles away. 1,2 over 0,8. On a good day, I'd be able to do that in my head. I shouldn't be able to do it in my head. 3 over 2, 1,5 meters. Okay, that's the highest the tree will ever get. It actually never gets to that height. It approaches that height. That's what we call a sum to infinity. Okay, I'm going to just go, there seem to be people a bit unhappy about number 7, and I'm not sure whether it was 7A or 7B or 7C. Okay, maybe you can just tell us which question you're not comfortable with. And I'm talking to the people online, because I think the people in the room were okay. I don't want to redo the question, okay? we've done the question and we have confirmed that it's correct each case. All right. Maybe you just wanted a bit longer to copy it down. Okay, so I'm just going to scroll to 7C. All right. Okay, what I will do, and we will share these answers as well as the answers to any missing questions that we didn't try. We will share these with the schools and we'll put them on our website as well. So, okay. All right. So let's look now, and this may be, we're going to go to question 12. All right? Because I want us all to look at question 12, and we'll start off looking at it together, right? And then we will see what we can decide. First up, I want us to look at the first differences. Is 12 minus 5 the same as 23 minus 12? No, this is not arithmetic. No. Right? Is 12 divided by 5? Now, 12 divided by 5, is that the same as 23 divided by 12? Do you think? It's not. This is not geometric. Okay. And then, if it's not arithmetic and it's not geometric, what is it? It's quadratic. I want all of you to try this question. Okay, the first thing I want you to do is I want you to find TN. Okay, for this sequence. Okay, I am watching the chat. There's still someone talking about question 7. Okay, so if you could just tell me, is it 7A or 7B or 7C?
Number 7, Bob.
All right, when you're ready to answer this question, just put your hand up. Okay, we're giving you time to try it. Okay, so we have got someone, I under the microphone over here, you found someone else, okay? All right, I'm gonna ask you just to wait a little bit. Once you get the microphone, just take the microphone. You can take the microphone, but just we're gonna just wait a little bit and let learners try this question. Guys, this question in an exam is probably 6, almost 7 marks. Okay, so you've got like 6 or 7 minutes to do this question. Okay. Let's go ahead and just wait 1 minute. Okay. All right. Just we'll take an answer here shortly.
Does it help?
Question now. Okay, that's good. That's great. Yeah, please monitor the chat. Yeah. If it's a question I haven't done, yeah. No, don't question now. Yeah. Okay. Yeah. So I didn't do. Yeah, that's a good idea. Can you send that to the post-it?
A bit of a
My girl keeps listening. I've been back to the time. Just, yeah. Okay. The man with the microphone. Yeah.
Well squared.
Okay, you give me us the final answer, or you're going to show us how to do it. I'd like you to show us how to do it, because what we don't want is for all the letters in the room to say, oh, that's okay, but how did you do it? Okay, what did you get for the first differences? Yeah. Yes. Yes, okay, so those are the first differences. Second differences? 4. Add 4 and 4 and 4. Okay, so what is A? A is of the first of the second difference. A is 2, yeah. Okay, then tell me how you get B. 3 lots of A plus B is equal to 7. Guys, that 7 is this 7 over here. Okay, it's the first term of the first differences. So what did you get for B? B is 1. Okay, that's an easy equation to solve. That's 6 plus B is 7. Subtract 6 from both sides. B is 1. Okay, how did you get the value for C? Okay, so A is 2 plus B, which is 1, plus C is equal to 5. Because that 5 is the first term of the entire thing. Okay, so what did you get for C? C is 2. Okay, now, it's Ruth there, I think, because I'm now hearing it. I'm hearing myself echo. Why don't you just mute? I don't know what's happening. I wasn't hearing that. That's so. Yeah, no. Okay. All right. So we get 2n squared plus n plus 2. Okay, before we carry on, because we're not finished, before we carry on, I always like to check an answer. For example, if n was 3, 3 squared is 9, plus 2 times 2 is 18, plus 3 is 21, plus 2 is 23. 1, 2, 3. Yeah, that looks right. Okay, T3 is 23. What did you do next? Yeah, 597. 2n squared plus n plus 2, okay. And then, yeah, yes,
Minus
595 is equal to 0, okay. And then,
n
quadratic formula, okay. So n will equal,
Oh,
yeah,
plus 1 squared.
so our b squared value is going to be 1 squared, yeah. Okay, over 2 times 2, 4, okay. And your final answers? 4? Okay, and which one are we going to take? Yeah, we're not going to have that one, okay. We're not going to have that one because n needs to be a natural number. Natural number 1, 2, 3, number 4, number 5, number 6. We can't have a negative number, and we also can't have a fraction. Okay, all right, guys. We're going to leave sequences there. I know there's some questions we haven't done. Not many. We've done very well. All right. We're going to go now into the paper 1 functions and inverses stuff. And what we've done here for you is a little summary of all the functions that you need to know, as well as all the transformations that you need to know. before we start this, okay, I'm going to open up some sketches, and we're just going to talk about the functions that you should know. Okay, that's rather interesting. There it is. It's trying to fall off the screen. Okay, the first one, the straight line function, the linear function. Okay, now it's got two things about it, mx plus c. M tells us the gradient, okay, and c tells us the y-intercept. So there, for example, is 1x plus 3. Okay, if we look at that equation, how do we find the y-intercept of any graph? We let x be 0. Now, if x is 0, that's not going to be there. Okay? And so there's the y-intercept of 3. Does it make sense? It always makes sense. Okay, all right. Notice also, guys, if we look at the gradient, this graph from here to here, it's rising 1 and it's running across 1. The gradient is 1. Okay, but if we change the gradient, I'm now going to make the gradient negative. I'm going to make it negative 2. And watch what the equation is now. Negative 2x, and I'm going to make that plus 4. Okay, I want us to see that the gradient is negative 2. Do you see that this line from this square to this square, how much are we dropping? 2. We're dropping 2. So minus 2. How much are we running across? 1. The x value is only changing by 1. So the gradient will be minus 2 over 1. It will be minus 2. How would I find the x-intercept of this graph? What would I do? I'd make y equal to 0. Okay, all right, so that's our linear function. The next one I want to talk about is the parabola, okay? And the parabola is basically the vanilla parabola is ax squared. Okay, now you might be surprised to see the a, but the a is important. And you'll notice also that the range is that y is 0 or bigger than or equal to 0. Okay, if I make a bigger, the parabola just gets tighter. If I make a negative, the parabola goes upside down. Okay, and what I want you to see now, look at the range. The range has changed, and we've now got a negative value. Guys, if you're online, please can you just mute yourselves? All right, because at the moment I'm hearing all of you. Okay. The people online, and I'm thrilled. You cannot believe how pleased I am that there's so many people online. Cordwa, please keep yourself muted, okay? Because otherwise, I'm hearing all of you, and it's very, very difficult for me to teach if I'm hearing all of you. I'm sorry. I know it's irritating to be muted. Okay. All right. So there we go. Okay. All right. Now, guys, there it is. What will happen, and this happens to any graph, what will happen if I add a number at the back of this equation? So at the moment, I've got negative 1x squared. What will happen if I make it negative 1x squared plus 2? You can all say it out loud. It will shift it which way? 2 up. There it is. Guys, that's what it looks like. And what will happen if I subtract 3 from every x value? If I subtract 3 from every x value, it will shift it to the right. Guys, the left-right shift works almost opposite to what we might expect. Okay, let me just make that exactly 3. And this is what we call the turning point form for a parabola. Notice the range now, guys. Look at the range. The range is y less than or equal to 2. Okay. And the turning point is 3, 2, because the graph has been moved 3 to the right and 2 up. The graph was over here, and it was turning at 0, 0. Now it's moved 3 to the right and 2 up. So picture that point moving 3 to the right and 2 up. It's now turning at 3, 2. Okay, there is another sketch for the parabola, and this is in its standard form. What does A tell us? It tells us whether the graph is okay. B doesn't really tell us anything on its own, okay? But remember the axis of symmetry. The formula for the axis of symmetry is negative B over 2A. So if I've got a value for B, notice that the graph can move. It will move left or it will move to the right. I want to just show you that if, for example, B is 4. Okay? Now, please mute yourself if you're online. All right. Okay. There we've got, thank you very much. There we've got our A value is 1, our B value is 4, our axis of symmetry is negative, the B value over twice the A value, there's the axis of symmetry. What does C tell us? It tells us the y-intercept. Okay. And so, for example, here, there I've got C equal to 4. All right. And there you can see the y-intercept of 4. Okay, the next graph that we're going to show you is, and we're just going through these quite quickly, all right? This little thing gets in the way. We're going to show you the hyperbola. All right, now, a few things about the hyperbola. It looks quite complicated, but this value k tells us which quadrants the graph is going to be in. If k is positive, the graph is in the top left and top right and bottom left. And if k is negative, it's in the other two quadrants, top left and bottom right. Okay, right. I'm going to put k back to a nice number that sort of works nicely, like a number like 9. All right, and you'll see these points here, 3, 3, and -3, -3. This graph has got asymptotes, and at the moment, the asymptotes are just on the axes. It's also got axes of symmetry. And those have a gradient of 1 and -1. There's the 1 and this one's the -1. Okay, now what will happen if I add 2 at the back of this equation? At the moment I've got 9 over x. What will happen to the graph if I add 2 at the back? It will shift 2 up. And I want to show you what happens. Everything shifts 2 up. The axes of symmetry, which were y equals x and y equals -x, have moved up by 2. The asymptote, which was y equals 0, it was the x-axis, is now y equals 2. Okay, and the range, the possible y values, remember range is how far up and down it goes, the y values, it can't equal 2. Right, notice the difference between an asymptote, y equals 2, and the range, y not equals 2. Okay, right, so there's that graph. The last one that we're going to look at is our exponential function, the last one we'll look at right now. Okay, remember the base. The base just tells us whether the graph is increasing or decreasing. Okay, again, we can pick it up and notice that as I'm picking it up, notice that the range is changing. Okay. There's some stuff missing here off the bottom of the screen, which we're not seeing. Okay. I think I'm going to stop there with those, and we're going to go back to our workbook, right? And we're going to just quickly remind ourselves of these things, right? If we put a negative in front of every x, we get a reflection in the y-axis. If we put a negative in front of everything, we get a reflection in the x-axis. All right, and then if we add to every x, the graph moves left and right. It moves left if we add, and it moves right if we subtract. Okay, and then lastly, if we add a number at the back, the graph will go up or down. If we add a number, it goes up. All right? And if we subtract a number, it goes down. Okay? You need to learn this page. Basically, you need to know this page. You need to understand all this stuff. If I say to you, Yinile, what is this thing? You know, it's a cell phone. You don't have to stop and think about it, okay? If I put a picture on the screen, and I'm just going to quickly try. Right. Yinile. Hyperbola. Okay. Yinile. Parabola. Okay. Yinile. Exponential. You asked it before I even drew it. Okay. But let's ask this question. What's the vanilla flavor for a parabola? What's the basic equation? Ax squared. What's the basic for one of these? K over x. And for this one? A, b to the x. Okay. All right. Let's look at some questions, guys. Okay. Just very quickly, remember that a function is only a function if every x uniquely defines y. Okay, and what do we mean by that? All right? We mean that for an x, we must only have one y. Only one y. Elilodwa. Okay. So, is 1a a function? Let's just look at this together. Is it a function? 1 is a function. No. 1 is not a function. Which point is preventing it from being a function? Natsinkiga. Here we've got an x that's giving us two different y's. X does not uniquely define y. Okay. We can say does not give only one y. All right. What about this one? Let's think of an x value. If we put 5 in, what numbers can come out? If we put 5 into here, what 5 plus 4? 9, square root of 9. 3, Norma, negative 3. Is it a function? No. Guys, it's not a function because one x value gives two y values. Right. If we've got a picture, sometimes we like to think of a vertical line, okay, which we can pass over the graph. Let's just do this one first. Maybe we can go back to some of you guys answering the questions. I feel like I'm doing too much work now. Okay, so put your hand up if you know whether this one is a function or not. Or Ruth or Sophia, and she will take your answer. And if it's right, she might even give you sweeties. Right, guys, any suggestions here? Yeah, here we go. Thank you. It's not a function. Which points are making it a non-function? So this is not a problem. This one actually is a function, okay? Because what we've got here, we've got the same y value, all right? But we've got different x values. These points are like that. If I was to pass a vertical line, okay, we would never hit both those points at once. What we're looking for, the problem comes in if we've got the same x value, with different y values. Look at this. The same x value with different y values, not a function. It is okay to have the same y value with different x values. This one is a function. Each x only gives one y. Guys, you might have learned x uniquely defines y. X does not uniquely define y. That's fine. But I think maybe the uniquely is quite a difficult word. Each x only gives one y. All right. What about y equals sine x? Can you guys draw a sine graph in the air? Just draw a sine graph for me in the air. What does it look like? Yeah, there we go. It looks like this. It looks something like this. Okay, that's not a very good one. In fact, my computer thought it was rubbish, so it rubbed it out. Okay, it rubbed it out again. Okay, but it thinks I'm drawing a, thinks I'm rubbing out. Okay, okay. Okay, all right, there it is. Okay, guys, can I pass a vertical line over this graph without it ever touching at more than one point? Yes, I can. Okay, I'm struggling to draw a vertical line, but there it is. Okay, and if I can actually select that vertical line, there we go. Watch, it never hits the graph at more than one point. Is this a function? Yes, this one is a function. And what we would write, each x, only one y. Okay, then, what about this one? No. Okay. Each x gives more than one y. Have a look here. If I put a vertical line on this graph, and I can put it anywhere, do you see that this x value here is giving a y value there? I'm going to call it y1. And it's giving a y value there. I'm going to call it y2. There are two y values for a given x value. It's not a function. What about the last one? Is it a function? It's a function. Okay. Yes. Each x, only one y. All right. Now, I definitely want some answers from you guys. We're going to look at these four graphs. Okay. And we are going to ask you for the domain and the range of each of them. But when you put your hand up, the first thing I want you to tell me is what sort of graph it is. Which function are we dealing with? Is it a straight line? Is it a parabola? What is it? Okay, so put your hand up if you know what graph we are dealing with over here. And then I want you to tell me the domain and the range for this graph. Okay, there we got someone putting someone's hand up for them. They don't want to put their hand up by a side. Okay, no, yes. I think you should take the lady next door who was putting their hand up. Yeah, that was, yeah. No, the one who was, you were holding your friend's hand up. I think you should tell us. Yeah, you tell us. What sort of graph is it? Well done, it's a hyperbola, okay? Well done. And now, I'm going to ask you this. Normally, for a normal vanilla hyperbola, x cannot be 0 and y cannot be 0. Tell me for this one, what will the domain, what can't x be? And for the range, what can't y be?
X cannot be 4.
Done? Well done. And the reason, guys, just the reason for that, if you picture the vanilla one, how's the vanilla one moved if we subtract 4 from the x? And how has it moved if we add 3 at the back? Can you tell me that? If you've still got the microphone.
Yeah, well,
How's it moved?
yeah, man.
It's
We are
moved
here.
4 to the right. And that's why that x not equal 0 becomes x not equal 4. And it's moved 3 up.
Yeah.
And the y not equal 0 becomes y not equal to 3. Now,
Yeah,
we haven't talked about the log graph. I'm going to draw for you here a vanilla flavored log graph with a base of 2. What the base tells me is that the graph is going to go uphill. This is what log base 2x looks like. The vanilla graph. For the vanilla graph, the range x can be anything bigger than 0. And the range y can be anything.
Okay,
guys, if you've joined online, why don't you just mute your microphones? Okay. Thank you. Right, now, who can tell me, what does this +4 do to the graph? Put your hand up. Put your hand up, take the microphone, get a sweet. Guys, we nearly had a break. I know you're tired, but I'm also tired. But we've got 3 minutes. What does this +4 do to the graph? Well done. 4 to the left. So, what will that do to the domain? What must x be? Remember, I can't have a negative inside here. I need x plus 4 must be bigger than 0. So what's the domain going to be?
Greater or equal to -4.
Not greater or equal to, actually greater than. Okay, I just want to show you, if I can find my calculator quickly. There's my calculator. Okay, guys, you cannot find the log. Okay, it doesn't matter what the base is. You cannot find the log of 0. For log, our domain, x must be bigger than 0. Oh, yeah, great. Ruth? Sorry, why don't you just quickly scuttle down here and give Elton my backy keys. Thanks. All right. Okay, so actually bigger than -4. And the range? Have you still got the microphone? No, it's got, no, someone's got it. Right? Yeah, what about the range? Well done, the y is an element of the reals. And then just make sure he knows where he's going. He's out here somewhere. It's Elton. Just make sure he knows cascades and tell him what he's doing. All right. Okay. Well done. Hala. Okay. Maybe you can get the microphone to someone nearby you and they can tell me, what sort of graph is this? This one says A, this guy says should be C, sorry. Okay. What sort of graph is it? I want someone with a microphone to tell me, what sort of graph have we got here? Well done. It's an exponential graph. Can you tell me, is this graph going uphill or downhill? And how do we know? Guys, remember that song by Megan Trainor? I've played it to you before. It's all about that base, about that base, about that base. Okay? If the base is less than 1, the graph is going downhill. Okay, so this is the normal exponential graph with a base less than 1. For this graph, the domain, guys, how far left and right does this graph go? It goes everywhere. X can be element of the reals. What about the range? For this graph, for the one that's drawn here. Y greater than, not equal to, y greater than 0. Guys, there's an asymptote here which it never touches. Okay, now, the man with the microphone, tell me what this is going to do to the graph and tell me the new domain and the new range. Well done. It's going to shift it down 9. Hello. So what will happen to the range? Y greater than -9. Hello. And the domain? It's going to be exactly the same. Still X element of the reals. Okay. Right. We're going to do one last question before we go to T. I want someone to take the microphone. I want to tell us what sort of graph is this? Okay, what sort of graph is this at the moment?
Today, did you smoke today?
Yeah. Okay, go for it. Tell us your name first. Sihle. Ngiyajabula ukukwazi. Okay, right, Sihle. Thank you. Tell us. It's a parabola. Is it a parabola like this? Norma like this? Which one? The sad one, okay? How did you know that? Because of this negative. See here, this graph that we've got right now, its domain, remember domain is how far left and how far right. This graph, the domain is x can be anything. The range at the moment for this graph is y less than or equal to 0. Sihle, tell me, how has this graph moved?
Why you yelling?
Well done. Hala. 4 units to the left. Okay? And what does this do to the graph? How's this shifted it? 9 units up. Well done. So if we picture that graph that we drew there, okay, if we shifted 4 units to the left and 9 units up, it's actually going to be somewhere kind of there. All right. Can you tell me what will the domain of this graph be? Okay, the domain will not change. The domain is going to be exactly what it was. It'll be x element of the reals. Okay, let's just help Sihle here, guys. What will be the Aha! I know why Sihle's gone quiet. Because he's saying, Agunjalo neze. Paul, ayikho. That graph is not there. Where's that graph? It's gone? Left. Sorry, guys. Okay, that graph has gone over here. All right, Sihle, so it's gone somewhere like there. What's the name of this point now, Sihle? Yeah, but what's its coordinates? It's the turning point? -4? 9. Well done. Guys, it was, this point here was 0, 0. When the graph moves 4 to the left and 9 up, that point becomes -4, 9. Sihle, the last thing you've got to do before we go and have some tea is tell us what is the range?
Does this sign?
Greater or less? Less. And can it equal 9?
Does this sign?
Yeah.
Can equal 9. Okay. All right. Guys, we're going to take a break now. And that is taking an equation and writing it into the turning point form. Okay. Because when we just see something like x squared plus 6x plus 11, okay, it's not obvious how that has been moved. Okay, before we do that though, I want us to quickly just make sure that we know how squaring a binomial. Binomial, 2 terms. How does this square? If we square this properly, all right, what do we get? We get a squared. What else do we get? We get AB and we get another AB, 2AB, and we get plus B squared. Halala. Okay, so what I'm going to highlight here, I'm not saying Ayanda yet, what I'm going to highlight here is that 2. Okay, there's Ayanda there, she can grab the microphone from me. Okay, so I want us to do another one, and maybe I've done this with you before, and maybe you're going to think, Paul, what do you need left? Okay, but let's look at Ikaya, not a very good Ikaya, plus Inhlanzi. If we square Ikaya plus Ihlanzi. What will the answer be? Hala, Ikaya squared plus 2 Ikaya Ihlanzi plus Hala. Okay, now guys, that 2 is really important. So what we going to do now? We are going to take this and we are going to try and write it as something squared. Now, remember the 2. 2. Okay. So, I need an x to get the x squared. Cordwa, what must I put here if I want to get 6x when I multiply it? I mustn't put 6, guys. I must put 3. And the reason I'm putting 3 is half of 6 is because of this 2. When I multiply this out, what will I get? X squared plus 6x plus 9. Okay, now I did not have 9 here before, so I must minus 9. All right, this is all on the same side of the equal sign. If we multiply this out, we get exactly as on the previous line. I want you to see why. X squared, yes. 6x, yes. 9 and minus 9, those cancel out, and plus 11. This is exactly the same as the stuff above it. Okay? All right? And let's just tidy it up. This is actually x plus 3 all squared plus 2. Now, who can tell me, if I had the normal parameter, y equals x squared, where is it happy or sad? It's happy. Where does it turn, guys? Where's the turning point? 0, 0. At the origin, thanks. I'm hearing some people online answering, which is very encouraging.
Yes.
Okay. Now, how has this graph moved if I add 3? And I want someone to put their hands up. I want you to answer 3 questions for me. How has it moved? And what is the new turning point? And then lastly, what is the range? Okay, so anybody want to tell me, how has the graph moved if we add 3 there and add 2 there? Put your hand up if you know. How has the graph moved? Someone put your hand, I want someone to put their hand up so that Ayanda can find you with the microphone. How's it moved? How much? Talk into the microphone.
3 units to the left.
3 left, good.
Yeah.
Add
2 units.
2 units up. Can you tell me what will the new turning point be?
New turning point.
Allah. Can you tell me, one last question before you give up the microphone. Can you tell me what will the range be? The new range, the range of this thing.
Greater than 2.
Can it equal 2?
Yes.
Yes. Greater than or equal to 2. Well done. All right. Now, guys, this next one is a little tricky, and I'm going to give you a bit of time to do it. But before we do it, what we're going to do, we're going to factor out the negative. Okay? What will go inside the bracket here? X squared, and then what? Minus 8x plus 6. Now, what I want you to do, I want you to work out what must go inside these round brackets and what must I also have here. So there's 2 places that I need you to fill some stuff in. I want you to write it down. I want you to tell me what goes there and also what goes there. And the big idea is that this must remain equals. Okay. All right. So if anyone's ready to tell us what I will need to put here. Okay. You can put your hand up. Ayanda will find you with the microphone. Okay, we've got someone with a microphone. All right, what must I put inside here? Halala. Guys, it must be x minus 4. I mustn't put minus 8 because whatever I put is going to get multiplied by the 2. So x minus 4. Okay, and then what? Well done, minus 16. All right, guys, because that minus 4, when it squares, it becomes plus 16. Okay, now, let me keep the microphone. What I'm going to do is I'm going to just change that 6 minus 16 to minus 10. And then I'm going to put that minus back inside. So negative x minus 4 squared plus 10. 10, not 11, 10. Okay, now, can you tell me, and what I've drawn here while I was waiting, what I've drawn here is y equals minus x squared. Is everyone okay that y equals minus x squared is a sad parabola? And where did it turn? It turned at 0, 0. Now, can you tell me, the person who's got the microphone, what does this do to that blue graph? Shifted which way? 4 to the right, and this 10 up. So can you tell me the new turning point of this graph? In other words, the turning point of this graph, what will the turning point be if we shift that point 4 units right and 10 up? 4, 10, halala. And then lastly, can you tell me the range of this function that we're talking about here, the range? Less than or equal to 10. It's less than or equal to because, guys, this is a negative parabola. It's going down. We can get the smallest values we like, but we can never get anything bigger than 10. Okay, does it make sense? Okay, Allah. Right, now, we're going to ask you, I'm going to give you a few minutes. I'm going to ask you to just draw rough pictures of these graphs, okay? And the first thing that you need to be able to do, you need to know what sort of graph is it, okay? So I'm going to give you maybe 5 minutes, which seems like quite a long time, but I'm going to ask you to try and draw all of them, these 4, okay? And then we're going to talk about them. Well done. Can you tell me, before you go any further, can you tell me, is it going to be in, and I'm going to draw a little picture here, which quadrants is it going to be in? Well done. All right, and guys, the reason we know that it's in those 2 quadrants is because of this negative value here. Okay, carry on. What else can you tell me? How's it moved? Well done. Well done. Okay. And now, because of that, I'm going to draw in the asymptotes, guys. The asymptotes are going to be there. And they're going to be there. Right. Remember, the asymptotes are normally on the axes. This here is the line y equals negative 2. And this here is the line x equals negative 4. Okay. Right. Now, because of where this graph is, and I'm just going to draw a very rough picture. It's going to have 2 interesting points. Can you tell me how to find these 2 points? Well done. Negative 8,5. Negative 9 over 4. Oh, it's fine. Sorry, find the x-intercept. Sorry. Okay, I'm just going to do that a little bit slower. So I'm going to quickly do it. That's going to be 0 equals negative 9 over x plus 4 minus 2. I'm going to add 2 to both sides. 2 equals negative 9 over x plus 4. Ruth's looking for you. Yeah, that's cool. So, okay, negative 9 over x plus 4. And so now we're going to multiply both sides by 2. So we can, both sides by x plus 4, sorry. 2 lots of x plus 4 equals minus 9. So 2x plus 8, and I think you said negative 8 comma 5. Yeah, okay, negative 8 comma 5. So I'm leaving a few steps out there. I hope people are okay with that. Negative 8.5. So in fact, guys, I haven't drawn this graph very well at all. Okay, I will try and just improve on it slightly. Okay, because it actually has an x-intercept of negative 8.5. So it's actually more like somewhere like that. Okay, and the y-intercept? Negative 4 comma 5. How did you find the y-intercept? You let x be naught. So you get negative 9 over 4, all right? And then, so negative 9 over 4 is negative 2.25, negative 4.25. That looks about right. Okay, I haven't drawn it exactly, but that is negative 4.25. Everyone okay with that? Okay. Right, let's go to someone else and let's see if someone can help us draw this one. And this one's maybe a little bit simpler. What sort of graph is it? Okay, yeah, what sort of graph is it? And who can tell me about it? Yeah, right. There we go. Someone's getting the microphone now. Well done. It's an exponential. Is it going uphill? Watch my hand. Is it going uphill or is it going downhill? How do you know? Well done. The base, this base is less than 1. So the basic shape is a downhill graph. Okay. Has it moved? Has this graph moved? And if so, how much has it moved? It's moved 4 down. Well done. Okay, now normally, what sort of asymptote does an exponential graph have? Does it have a horizontal one or a vertical one? I'm asking the man with the microphone, but a lot of you have helped him. Yeah. It has a? They were all right, by the way, yeah. No. You should have gone with what they said. It has a horizontal asymptote, and that horizontal asymptote, guys, has moved down. Okay. So now our graph's going to come down. I'm not going to draw it properly yet. I'm just going to draw like something like that. How would I find this point over here? How would I find that y-intercept? Well done. So to find the y-intercept, we're going to let x be 0. What do we get for y? So what's a half to the 0? Half to the 0 is 1. 1 minus 4? Negative 3. Guys, the y-intercept is there. How would we find the x-intercept? I'm still asking my friend with the microphone. Let y equal 0. Okay, so let's focus, guys. 0 equals a half to the x minus 4. We want to solve this equation. Can you tell me how we're going to do it? What could I do to both sides first? Well done. We're going to add 4 to both sides. And we've got a half to the x. Okay? Now, we could try and change the bases on both sides. Norma, what else could we do? How do we solve equations when the variable is in the exponent? Well done. And what's the answer if we use logarithms? What would we put into our calculator? What would we put into our calculator? Log base of 4. Okay, and guys, the answer you actually get, I think, is negative 2. Okay, negative 2. So that is our x-intercept. Remember, the other way of solving this is to try and get both of these with the same base. And if you did that, 4 is 2 squared and 2 to the minus 1. So we actually get 2 to the minus x is 2 squared. And that's why x is minus 2. It makes sense. It always makes sense. Okay. All right, guys. Have you still got the microphone? No. Okay. I'm just going to ask all of you to tell me, what is the domain of this graph? How far left and right does it go? Well done. X is an element of the reals. What about the range of this graph? Y greater than 4. Guys, it never, not 4, negative 4. Okay, it never touches that. All right, next up, log graph. And I suspect you guys aren't very comfortable with log graphs. But who can tell me if this log graph is going uphill or downhill, and how do I know? All right, anyone with a microphone, please. Easy question. Is it going uphill or downhill? I'll help you. It's going uphill, guys. It's going uphill. Now, a normal log graph has a vertical asymptote. So that's what this graph looks like, the vanilla version. When I say the vanilla version, before it has moved. All right, now I'm looking for someone to tell me, how has this graph moved compared with the vanilla version? Shifted 4, which way? 4 to the left. Guys, normally the asymptote is on the axis. Now the asymptote is going to be here at x equals minus 4. All right. What I need to find out is, what is the y-intercept going to be? So it's going to go somewhere like this. Okay? I don't know where it's going to go. It's going to go something like that. How will I find the y-intercept? Ideally, I'm looking for someone with a microphone. Okay. All right. Yeah, this person over here is going to tell us how to find the y-intercept, and maybe also even how to find the x-intercept. How will we find the y-intercept? Well done. So let x be 0. And what is log base 2? Guys, if x is 0, what is log base 2 of 4? It's what power must I put onto 2 to get 4? 2. Okay, so the y-intercept of this graph is 2. How are we going to find the x-intercept? How are we going to find the x-intercept? Yeah. So now we've got 0 is log base 2 of x plus 4. Are you able to tell me how I'm going to solve this? Because what I need to do is I need to take it out of log form. So I want you to I want you to use an exponent form now. Yeah. Well done. Okay, guys. I want to say something that I said all the time, and I'm hoping you remember it from the videos. The base is always the base. Okay. Now 2 to the 0 is 1. So we've got x plus 4 equals 1. So x must be, subtract 4 from both sides, minus 3. And there's the x-intercept. So guys, this graph looks something like this. Okay. What's the domain? We're talking about domain, we're talking about left and right.
X is greater than x is 4.
Well done. And what's the range? And remember, for range, we're talking about up and down. Allah, Allah. I think that gentleman deserves a round of applause. Okay, now, next up, we've got this one. X squared minus 5x plus 6. Okay, anybody want to tell us how we're going to draw this graph? Here we go, we've got a hand, thank you very much. What graph is it? What sort of graph is it? Parabola. And is it a happy one or a sad one? Happy one. So it's like that. Okay, great. What can you tell me? What else can you tell me about it? Yes? Well done. And we found the y-intercept by letting x be 0. 0, 0, 6. Yeah, great. Okay, let's find the x-intercepts. Let y equals 0. So x squared minus 5x plus 6 equals 0. Yeah. Can you factorize that for me? Okay. Yeah. So both sides must be negative, because I want to end up with a negative number here, but also the signs must be the same to give me the positive. And then you said 3 and 3 and 2. Great. Okay. So what are the x-intercepts? X equals what or what?
X is equal to 3 and x is equal to 2.
Okay. So there's 3 and there's 2. Okay.
Then we need to.
Yeah, I'm just a little bit worried about this graph. Something's going on here. Yeah. Am I wrong? Yeah, sorry, I've drawn that point in completely the wrong place. Sorry, guys. Yeah, they are here and here. Yeah. Okay, carry on. Yes. How are we going to do that? Yeah. Yeah, so what do we get? X is? It's going to be 5 over 2.
Yes.
5 over 2, guys, is 2.5. It makes sense because it must be in between those two values. Then, if we square 2.5, we get 6.25. 5 times 2.5 is 5 times 2.5 is goodness, it's 5 times 2.5. My brain is now turned off. I think it's 12.5. Okay. So we've got 12.25 minus 12.5. I think we're getting minus a half. Did you guys do it on a calculator or not? I think it's minus a half. I think it's 5 over 2, negative a half. I think so. Okay. I hope I'm right. Am I right, guys? No? I am. Okay, great. Thank you. Well done. Before you go, last question. Tell me about the domain of this graph. Remember, domains left and right. Well done. And tell me about the range of this graph.
Y must be
Sorry, is this negative 1 over 4, guys? Okay, thank you. Sorry, thanks for fixing that. I did that in my head and I got it wrong. Negative 1 over 4. Okay, negative 1 over 4. Well done. Okay. Sorry? Are we okay? Yes? No?
Yes.
Okay. All right. If it's wrong, guys, you must tell me.
Let's move on to the
Now,
language.
okay. Now, I want us just to quickly look at this, and I know you haven't had a chance to look yet, so I want just try question 5. How are we going to do these? Most of them are quite easy to do. Okay. All right. I'm looking for an answer for 5A. I want someone, don't worry about putting it in standard form, but I want someone to tell me what must I do to take that graph and shift it 3 to the left and 2 up. Okay. All right. So Ayanda's got the microphone. Put your hand up if you know what I must do to shift it 3 to the left and then 2 up. Yeah,
So in order to get out to shift 3 to the left and 2 out, we should add
we should add 3 to shift it left. And should I add 3 to this x, Norma, this x? I must add 3 to all the x's. Okay, guys. That will move that graph 3 to the left. I've added 3 to every single x, not just to some of them, to all of them. And now, how must I move it 2 up? I must plus at the back here. Okay. Guys, we're not going to spend time multiplying that out. To put it in standard form, we would need to multiply it out. We're going to leave that there. What I want to just quickly highlight for you here is that the 3 left is coming about from those 2 plus 3's. And the 2 up is coming about from the plus 2 at the back there. Okay, well done. Thank you. Next person, I'm looking for what must I do if I want to reflect this graph in the x-axis?
Must multiply y by -1.
Well done. Okay, I heard it online, so I'm going to take the online answer. I must multiply y by -1. Okay, what that actually means is I must make all of the stuff that used to be y, I must put a negative in front of it like that. I'm basically putting, you might say we're putting a negative there. Norma, that's the same as putting a negative there, all right? Okay, and the final answer, if I do simplify, it will be -3 to the x minus 5. Okay, and I just want to quickly draw a little picture of what's going on with the original graph. What shape is this original graph? It's a exponential. Is it going uphill or downhill? It's going uphill, guys. The base is bigger than 1. It's going uphill, and that 5 is moving it up. That's what that graph looks like. Okay, now this graph here, if I had to draw this graph, and I'm going to use the black pen to draw this graph, okay, 3 to the x is going uphill, -3 to the x would reflect it, and then the -5 would drop it down by 5. And so what we're hoping you're seeing here is this reflection in the x-axis. Okay, I'm now looking for an answer of how to take this hyperbola and reflect it in the y-axis.
You multiply the denominator by -1.
Yeah, it's actually not the whole. Have we got someone in the room here? You close. It's not quite right. The person online. Anyone in the room? Yeah, tell us. Well done. You don't need to do that. We'll just leave it like that. Okay. I'm happy with it just like that. Okay. Guys, to flip a graph, to reflect a graph in the y-axis, all we do is we put a negative in front of the x. Every x, however many x's there are. Right. Thank you. Next up, who can tell me what sort of functions reflect in the line y equals x? Well done. I'm hearing it from a few people, so we won't go to the microphone. Inverse functions. Now, who can tell me how to find the inverse of this function? Yeah, we've got some answers down the front row here, right in the front row with the blazer on. Guys, I'm going to, while we wait for the microphone to get to this gentleman, I'm going to just quickly tell you that if I put 2 into this function for x, I get 4 out. The function that this gentleman's going to help me find needs to do the opposite. When I put 4 in, I must get 2 out. Okay, tell me what I'm going to do. Is it on or not? Just check. There we go.
First thing you have to do is to interchange.
Okay.
N equals to 3 to the fourth y minus 5.
Well done.
Then you introduce the logarithm.
Okay, I don't think we're going to introduce the logarithm just yet. Okay, add 5 to both sides, yeah. Okay, so what will y be?
Y will be equal to log of 3 to 3 and 8 plus 5.
Well done. And guys, watch what happens. When you put 4 in here for x, you're going to get 9 inside the bracket. This here is going to become 9. Okay? And what power must I put onto 3 to get 9? The answer is 2. Your answer is definitely correct because it took the 0.24 and it inversed it. Okay? In other words, 2 as an input, 4 as an output, 4 as an input, 2 as an output. Okay, right. We're moving, well done. We're moving straight on. We're going to do just 2 more inverses. We're only going to do 2. We're going to do C and D. I want someone to tell me how to do C. I also want someone to tell me how to do D. We are finding the inverses of these 2. Someone got the mic. Yes. You're not sure about C. Okay, let's work on it together. Okay, so if I make this y equals, okay, and I'm going to do that first, and then I'm hoping that might help you a little bit. What's one of the, once we've got x's and y's, what's the big idea? Can you keep the microphone? Okay. What's the big idea now that we need to do next if we're finding an inverse? You know. Okay, so remember for the inverse, we want our point to swap around. So for example, if x was 5, I'm just going to quickly work out, we get -2. We want the inverse to turn that point around. Okay, so we wanted to do that. So let's swap x and y. So all the y's we're going to write as x's. All the x's we're going to write as y's. Now, I want you to tell me what I want to do now. I want to get y on its own. What could I do to both sides to make it a little bit better? We're going to swipe. Swap. No, sorry. No. We've got, what should I do about this -5? Let's add 5 to both sides. Okay, now I'm not sure if you get, maybe you know this. How can I take this out of log form into exponent form? And I'm going to give you a hint. 2 to something equals something. What must I put where? Sorry, this is, what on earth is going on here? Yeah, that's fine. 2 to that? Well done. Cool. The last thing we need to do is we need to get rid of this plus 3. So what will it be? Well done. Very nicely said. 2 to the x plus 5 minus 3. Okay, and the very last thing I'm going to do, I'm going to change this name to f inverse. Okay, well done. Let's just, guys, I want to check this answer. All right. If we put minus 2 in here, minus 2, we get 3 on the top. 2 to the 3 is 8. 8 minus 3 is 5. It works. Okay. Sorry, guys, this is 3. This is 3. Okay. Now, there's something a little bit interesting that happens with parabolas. Anybody want to show us how to find the inverse of this graph? Yeah, so we've got in the front row here, we've got someone with their hand up. Yeah, cool.
My name is Nino.
Great.
So first we have to find x and y.
Yeah.
Oh,
Yes.
hey.
Yeah.
Yeah.
Yeah. Okay, so x plus 4 is actually y squared. Yes. Yes.
So for inverse function to be a function, you have to illustrate by f should be greater than or equal to 0 or x should be greater than or equal to 0.
Sure. Yeah, well done. Yeah. So which one are you going to take now? Okay. And then must this be a plus or a minus? Well done. Okay, and the last thing we're going to do, we're going to write it in inverse notation. Okay, very, very well done. I'm hugely impressed. Okay, this is probably one of the more complicated things in this topic. I'm just going to draw you a little picture. Guys, x squared minus 4 looks something like that. Okay, that's what that graph looks like. Now, if we had plus or minus the square root of x plus 4, it looks something like this. No, it can't possibly look like that. Okay. Yeah, it does look something like that, but not quite, not exactly like that. Yeah, I'll draw it. I'm going to draw them both for you on my computer. Right, but the inverse would not be a function. Okay, so in fact, what our friend here has done is he said, let's only have the left-hand side of the parabola. Okay, and if we only have the left-hand side of the parabola, then we will only have the top half of the inverse. Okay, this point, guys, would be 2, 0, so this point would be 0, 2, all right? This is 0, negative 4, so it will go somewhere like that. Okay, I haven't drawn this very nicely at all. Okay, and the line will be yeah, guys, I'm not happy with this picture. I want to quickly draw it for you on my computer, just so we can be completely comfortable with it. Okay. I think my picture was confusing there. Okay. All right. So we're going to draw y equals the square root of x. Sorry, we're going to draw y equals x squared minus 4. And then we're going to draw y equals the square root of x plus 4. Okay, and what we'll see, if we draw the line y equals x, we will see that reflection. Okay, so what I'm going to do now is I'm going to rub out this. All right, and I haven't got the bottom half of this graph, so that's kind of what it looks like. I don't know if my one looked like that. Yeah, this is this green graph. Thanks. I'm glad I drew it on the computer because this green graph's in completely the wrong place. Okay, this green graph is actually like that. Okay, all right. It's the top half of the parabola on its side, and this is the right half of the parabola. Sorry about that. Okay, right. Now I want to move on to trigonometry quite soon. So I want to go specifically to this last question, which is question 10. Okay, and this question is all about interpreting functions. Okay, so we're on page 12, right, which is halfway through the workbook, which is slightly alarming. Okay, all right. Okay, guys, do you agree that when we find f of x equals 0, what we're doing is we're letting y be 0? What sort of points are we finding if we're letting y be 0? We are finding, well done, we're finding x-intercepts. So at the moment, the function has got 3 x-intercepts. Now, we're going to do this together. Is this going to be a up-down or a left-right? Guys, if you add a number at the back, well, it will be an up-down shift. Okay, now if I pick this graph up, okay, do you agree if I pick it up a long way, it will only end up with 1 x-intercept? It's going to look something like that if I pick it up a long way. Do you agree? How much can I pick it up so that it has exactly 1 root? I need to pick it up by more than what? I need to pick it up by more than 20,7. Because if I pick it up by more than 20,7, it will only have 1 x-intercept. But do you agree, if I drop the graph down far enough, do you agree it will start to look like this? How many x-intercepts has it got now? Also only 1. Now, what must t be if I want to drop it down enough that I'm going to get only 1 root? Okay, it'd be useful to have someone with a microphone to hear what you're saying, or shout it out loudly. Yeah.
Putting to less than 12,6.
Less than 12,6? Not quite, because if I want the graph to go down, must t be positive or negative?
Negative.
Yeah, so in fact it must be less than negative 12,6. Are we okay, guys? We want to drop the graph down by more than 12,6. This one is positive because I'm picking the graph up. Cordwa, this one is negative because I want to drop the graph down. Okay, now we're going to look at question B. And I want you to look at the position of this. Is this, inside the bracket, is this an up-down or a left-right? It's a left-right. Now it says, for what values of k will the graph have only positive roots? At the moment, it's got 2 negative roots and 1 positive root. I want someone to put their hand up, and I want you to tell me in English, how must I move the graph if I want all the roots to be positive? How must I move the graph if I want all the roots to be positive?
4 units. To
I'm
the
hearing
right.
an answer. Well done. I'm hearing an answer online. I must move it more
Ay, ma'am, ese es seriously. Ay, no.
more
Seriously.
than 4 to the right. Now, guys, to move a graph to the right, must the k value be positive or negative? Negative. Okay, so I'm thinking about numbers like -5. -5 would move it 5 to the right. -6, -7. So, what must I put over here? Less than. Well done. I need less than -4. Okay, less than -4. Because I need numbers that are more negative than -4. Okay, this one here. Is this an up-down shift or a left-right shift? This is an up-down shift. Well done, okay? Now, at the moment, there are 3 separate roots. Okay, if I move it up just a little bit, there will still be 3 separate roots. But I can't move it up by more than 20,7. So t must be less than 20,7. Because if I move it up by 20,7, then I would have only 2 roots, because the graph would actually turn at that point. So I must move it up. I can move it up 3 or 4 or 5 or even 20, but I can't move it up more than 20,7. In fact, I must move it up less than 20,7. How much can I move it down and still have 3 roots? I can move it down by 12,6. And remember, to move it down, I must have negative. But I can't move it down by more than 12,6. So there's my answer for that. T can lie anywhere between negative 12,6 and 20,7. People do find these questions quite hard. Okay? And then the last question, and I'm going to scroll a little bit and just redraw this graph. Okay? Is this a left-right or an up-down? Left-right, well done. Okay, so guys, the graph looks like this at the moment. -4, -1, and 3. Okay, if I want all 3 roots to be the same sign, I've got a choice. The one thing I could do, I could move it so they are all positive. And remember, we've already done that. K less than -4. We did that over here. All right, there it is there. What's the other option if I want all the roots to be negative? How must I move the graph if I want all the roots to be negative? So this is moving it more than 4, right? What's the other thing I could do to get all the roots the same sign? This here would make them all positive. How can I make them all negative? Move it more than 3 to the left. Now, what must k be to move this whole graph more than 3 to the left? K must be greater than 3. Okay, remember, positive values are going to move the graph to the left. Okay. All right, we're going to do just, I'm actually going to leave these questions, all right? I will give you the solutions to them. All right, I will share the solutions with the teachers. I will do these questions in my own time a bit later. I hope you'll try them as well. And we're going to now get into some trigonometry. All right, so the big new ideas, guys, in grade 12 is this stuff. This is the new stuff from grade 12, for grade 12. It doesn't mean you don't need to know the other stuff. Of course you need to know the other stuff. But you need to know this stuff, and you need to know it really, really well. You need to know it backwards, and you need to know it forwards. Okay? Right. So, remember that we've got some special angles. We know how to calculate without a calculator. We know how to calculate angles for 30, 45, and 60. These are special angles. We can either draw the little fan or we can use special triangles. I'm looking for someone to tell me, how can I use one of my new formulas to find cos of 15 without a calculator? Cos of 15 without a calculator.
Cos 45 minus 30.
Okay, I've got an answer. I don't know if people heard it in the room. I heard it, and you're absolutely right. I'm just seeing if anyone in the room can tell us.
Is. Or it could be either 60 minus 45.
Cos? Okay, well done. So 45 degrees minus 30 degrees. We could also use 60 minus 45. Absolutely. Now, what is the expansion for cos of something minus something? Which one are we going to use? There it is there. Okay? It's going to be cos 45.
Cos
Yeah, carry on. You tell me. Thank you.
plus
Yes. Well done.
45 sin 30.
Okay. And now, what is cos of 45? I can get, guys, I can actually get these off a calculator, okay? But, well done, square root of 2 over 2, cos of 30.
Root 3 over 2.
Okay, and sine of 45.
Root 2 over 2.
Yeah, and sine of 30.
Half.
Half, 1 over 2, okay. If we simplify all of this, guys, we're actually going to get the square root of 6 over 4. And here we're going to get the square root of 2 over 4. We're actually going to get the square root of 6 plus 2 all over 4. And we are lucky because our calculators and my sister and I, okay, I'm going to tell you guys a quick story, okay. My sister Ruth and I, we both wrote matric maths, okay. And when Ruth wrote matric maths in 1987, okay, she was allowed to use a calculator. When I wrote matric maths in 1985, 2 years before her, I was not allowed to use a calculator. Okay, and so we both got A's. Ruth got an A for matric maths, but she used a calculator. I got an A for matric maths, no calculator. Who do you think? Which of you think I'm cleverer than Ruth? Allah, surely. Right, guys, can I tell you something? Ruth's calculator that she used, it couldn't do this. Ruth's calculator did that. Okay, it only did that. And so, and if Ruth gave that as an answer, the teachers would know, she has cheated. She's used her calculator. Okay, you guys are very lucky with a calculator now that actually does a lot of this stuff for you. Okay, it simplifies surds, it simplifies fractions, it does all sorts of cool stuff for you. Okay, let's see if we can do this one without a calculator. Now, the first thing we're going to do here is we're going to reduce. We're going to use our reduction formulae. Okay, remember this, all sine, tan, cos. Okay, I'm looking for someone who can reduce all of these numbers for me. Which quadrants, by how much? Yeah, there we go. Thank you.
To reduce cos 195 degrees is going to be cos 180 plus 15.
Yes.
Which is the quadrant.
Well done.
Next to 85 is going to be sine.
Okay, so let's just quickly finish that. Will it be positive or negative? Negative cos 15. Thanks. Okay, carry on.
Sine 285 is going to be sine 270 plus 15, and it's going to be a negative sine 15.
Just careful, it won't be sine. If we're 270, we must go to Cos, yeah. Okay. Yeah, cos 15. Yeah, carry on.
Cos 9 plus 50,
Yes.
which is going to put cos 15. The sine 15,
Will it be positive or negative sine 15?
positive.
Cos in quadrant 2. So cos 105, we are in quadrant 2. Is cos positive or negative in quadrant 2?
Negative sine.
Yeah, so this will be negative sine 15. Guys, the reason it's sine rather than cos is because we're off a vertical axis. And then this one is sine 15 as well. Okay.
Yes.
Okay, so what we've got we've got cos squared 15 minus sine squared 15. Now this is the right hand side of one of our triangles. Which one?
Where are you?
Yeah, move the
Hello.
move the.
Yes,
Yeah.
Cos squared 15
Minus sine squared 15 is the same as cos of
Xe không nào rồi.
2, well done, cos of 2 lots of 15. And that's cos of 30, and that's a special angle. Now, if you go to your calculator now, and you say that's root 3 over 2, okay, because you've shown us all the work. Okay. All right, well done. Next up, I want someone to try and simplify this for me without a calculator. So again, we're going to do a reduction formula. Okay, Ruth's running. I don't know how many steps she's got. I've got 3,760 steps. Maybe she can tell us just now how many steps she's got for the day. Yes.
Sine 40.
Well done. It's exactly the same as sine of 40 degrees, guys. And that's because we're in quadrant 2. Sine's positive in quadrant 2. We're 40 away from our horizontal axis. Carry on.
Yes, yeah. Let's go.
Negative cos 60. Well done. We're in quadrant 3. Cos is negative in quadrant 3. Right? And we're 60 degrees away from our horizontal axis. This, guys, this is a special angle. That's cool. This one, not a special angle. Okay, yes, but not right. Let's not worry yet. Okay, carry on. Yes. Yeah. Okay, positive or negative? Negative sine 20, halala.
Negative.
Yes. Cos of 20 degrees. Okay. All right. I'm a little bit worried because this is not a special angle. This is not a special angle. This one is. Yeah, carry on.
Cos 1 is a cos minus 1.
Yeah, so the best way to, this is just, the best way to just put that into a calculator or a cos graph. Guys, if you know what a cos graph looks like in your head, it gets to -1 halfway through. Okay. All right. Any ideas what we can do now? This is fun. The cos 60 is fun. It's a special angle. Okay. What can we do with sine 40? Do you know? Yeah. Okay. All right. So sine 40 times -1/2. Yep. Okay. All right. Yeah. Yes. Okay. Okay. Now, guys, that's very well done, and it's correct. Okay. I think many learners might not spot that. Okay. So many of you might have been happier changing sine 40 to sine 2 lots of 20. Okay. But this is very, very good maths that you've done here, because what you've seen is you've seen that and you said that's actually quite like that. Sine times cos. We haven't got the 2, which is why it's not sine of 40, it's half of sine of 40. Okay, what's your final answer for this question? Negative 1. Okay, all right, and negative 1 is exactly right. Could we check it with a calculator? Absolutely, impaired. Okay, very well done. Okay, as teachers, we like these questions, okay? The reason we like these questions is because your calculator does not help you. You need to know what you're doing now. All right, I'm looking for someone who can tell me in terms of M, we'll try and go quickly and just have one at a time. Yeah, just what is cos 193? Where is it? What's it? Yeah. Okay, 180 plus 13, guys. This question is all about 13. So well done. And so what does that become? Negative cos 13. Correct, because we're in quadrant 3. Yeah. Halala, well done. Next person. Next. Someone else now. Sine of 283. Sine of 283. Someone else. Ruth's running. Gee. Sorry, so it's going to be?
Cos 270 plus 15. The sine 270 plus 15.
Yeah. The sine of?
270 plus 15.
Yeah, so we want to try and we want to try and make 13. We want to try and include 13. So what must I add to 13 to get?
270.
270, okay, yeah, 270. Okay, now which quadrant will I be in? Well done. And is sine positive or negative in the fourth quadrant? Okay. What must I do? Must I leave it at sine or must I change it to cos if I've come off a vertical axis? No, if I come off the vertical axis, I must change it to cos, yeah. Okay, and I think the teachers in the room might tell me, Paul, we don't need to know 270, okay? I teach it anyway because it works the same as 90. So now, what's our final answer there? Negative? Just negative m. Well done. Allah. All right. Sine of 347. Negative 347. Someone. Yes, sorry. We're going to need a triangle soon. Okay. So far, I haven't needed a triangle. It's not wrong. We're going to need a triangle very soon. Right now, in fact. Okay. Who can tell me? Who can make this look a little bit better for us? It's sine of negative 347. What? Can someone improve this for us somehow? What can we always do, guys? We can always add 360. Norma, we can subtract 360. So what happens if I add 360 to this one? Hi.
So to write that, we're going to say sine. Negative sine equals 7.
Okay, you can absolutely do that. Okay, or you could add 360 degrees. And if you added 360 degrees, you'd have got that. Okay, but that's fine. Carry on. 360 minus 13, that's right. So it will come to, guys, sine of 360 minus will be negative sine 13. Okay. It will come to sine 13. Now, what I want you to keep the microphone. Tell me how are we going to, and someone already started talking about it just now. How are we going to now find out the value for sine of 13 when we only know about cos of 13? Use a graph or a little diagram. A triangle, okay? So, what should I put over here? 13 degrees, okay? What should I put over here? Well done, that's M. That is either the adjacent or it's our X value. If I'm in the Cartesian plane, it's our X value. What should I put over here? 1, well done. That is our R value or our hypotenuse. Okay. And then what does this come to? Well done, halala. And so what is sine of 13 going to be? Well done. Okay, over 1, which there it is. Okay, excellent. All right. Okay, I'm looking for someone to help me with cos of 386. Cos of 386. Okay, go for it. Okay, 360 plus 26. Yes? Because 26. Halala. Okay. Now, guys, nothing here. Because this whole question is about 13.
Okay, you say cos 2.
Well done. Cos 2. Well done. 26 is 2 lots of 13.
And I took 2 cos 12.
Okay, so there's 3 different options you've got now for cos of double angle. Which one are you going to use? Which would be the best one to use, do you think?
I took 2 cos squared.
Well done. 2 cos squared is the best one because we were told about cos. All right, so this is going to be 2 cos squared 13 minus 1. And so final answer in terms of M? Well done. Allah. Very, very good. Nicely done. Okay. All right. Now, 6.5. Wait a minute. Eyeball. Okay. Who can tell me how is 6.5 related to 13? 6.5 related to 13. Yeah.
Half angle. 6.5 is half 13.
It's half of 13. Well done. Yeah.
Yep.
Cos 18 plus 2.
Okay, yeah, I'm not so we can't do, yeah, I'm not sure exactly what you're saying. Just carry on, just talk a bit. I'll listen and I'll see whether I'm going to write it down or if I'm going to try and explain it slightly differently. Yeah.
And over 2.
No, so it can't, okay, so we can't halve the angle or halve the ratio. Okay, but keep the microphone, okay? Because do you agree that this is the same as cos of 2 lots of 6,5? Is that the same? Yes. Now, okay, do we know what this is on the left in terms of M? We do. It's just M. Okay, now, cos of 2 lots of 6 comma 5. I've got 3 choices for which double angle formula cos I want to use. But remember, I want to find cos of 6 comma 5. So I'm going to use the one that says 2 cos squared 6 comma 5 minus 1. Okay. Now, guys, just think about this. What we are wanting to find is what is the cos of 6 comma 5. And here we've got it in an equation. Let's try and isolate the cos of 6 comma 5. Who can tell me what should I do to both sides? Let's add 1. Good. Let's add 1 to both sides. That will give me 2 cos squared 6 comma 5. What could I do next? Divide by 2. M plus 1 over 2 is cos squared of 65. Not 65, 6 comma 5. And what's the last thing I should do to both sides?
Introduce square root.
Well done. Introduce the square root. And if I do that, do I need, and I want you to think about 6.5 degrees, which quadrant is it in? Do I need plus or minus when I square root? No, I don't need the plus or minus.
No.
There's the
That's
answer.
quite right.
Guys, that's a little bit difficult, eh? That's a sort of question for me in an exam that is a P, a problem-solving question. It's quite hard. Kodwa, if you've seen it before, it becomes easier. And that's why the more past papers, the more practice you can do, the better. Okay, now, Margie, that's in Kinga in cool, because they're asking us to draw sine x cos 30 plus cos x cos 30. High ball, I've never seen such nonsense. Trig graphs. Where? But they're also asking us to draw cos squared x minus sine squared x. All right, who can help me? Yes.
There's a compound.
Well done. What is it? Yeah, x plus 30 or 30 plus x. Allah. Guys, do you agree that's not difficult to draw? That's much better. Can you tell me, while you've got the microphone, that's just a sine graph. What does this plus 30 do to that sine graph?
It shifts the sun.
100%. Well done. Okay, great. All right. So we'll draw that graph just now. Can you tell me, while you've got the microphone, what can you tell me about g of x? Which one is it? And that is much easier to draw. While you've got the microphone, can you tell me, what does this 2 do to the graph of cos? 100%. Okay, right, guys. Very quick lesson on trig graphs. Just remember that our cast diagram helps us draw them. Thank you very much. All right, so my basic sine graph, and guys, you need a picture in your head. If someone says to you sine graph, you need to know that's what it looks like. It goes up to 1 and it goes down to minus 1. In the same way, if I say to you y equals 3x squared, you need to be able to do that with your hands. It's exactly the same stuff. It's functions. Okay? Let's quickly talk about a cos graph. A cos graph, and the reason maybe I didn't make this explicit or clear, the reason this is useful, this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. Positive, positive, negative, negative. A cos graph is positive in quadrant 1. Then it's negative in quadrant 2. It's still negative in quadrant 3. And then it's positive in quadrant 4. Do you see how I'm using this to help me draw this? I hope so. Okay. And guys, earlier we asked about cos of 180 degrees, and we know straight away it's minus 1 because a cos graph is halfway through its life. Okay. Now, let's draw the sine graph, but let's shift it 30 degrees to the left. Normally, sine of 90 is 1. Now, sine of 60 will be 1. Normally, sine of 180 is 0. Now, sine of 150 is 0. Normally a sine graph gets to its minimum at 270. It's going to get there 30 degrees earlier. Okay, and then lastly, normally at 360, a sine graph is back at 0. Now it's going to be there. All right. We can also work out how would we work out the y-intercept of this graph? Of any graph, how do you work out the y-intercept? You let x be 0. What's sine of 30? It's a half. So guys, what we've got here, we've got our sine graph. It looks something like this. Has the period of this graph changed from the vanilla one? Guys, has the period changed? The period has not changed. What's the normal period for a sine graph? 360 degrees. After 360 degrees, I'm back at a half. I'm back where I started. Okay. Now, our friend over there said that the cos graph, the period has changed to 180 degrees. This number 2 here is saying we're going to get two times more graphs than usual. Okay, remember the basic shape of the cos graph? There it is. Instead of, basically guys, I've got to fit a full cos graph in between 0 and 180. Everything happens twice as early as before. Normally a cos graph is at the bottom, normally a cos graph is at 0 at 90, now it'll be 0 at 45. Normally a cos graph gets to the bottom of its life at 180, now it's going to get there at 90, because that 90 will be doubled. 2 lots of 90 is 180, so it's going to behave like it used to behave at 180. Okay, now, normally at 270, it's back at 0. Half of that is 135. It's going to be back at 0 somewhere there. And then do we see, it's done a full graph, and then guys, it's just going to do exactly the same again. It's going to come down here, all right, at 270, it's going to be at where you're at -1. It's going to go there, and then it's going to go there. Okay, I haven't drawn it beautifully, but there it is. Okay, then, and this is an interesting question now, because it says calculate where those graphs intersect. Don't read it off your graph, calculate it. It looks like they might intersect 4 times. 1, 2, 3, 4. And now this is an important question that we're going to do now. Yes.
So we have to equate the two graphs.
Correct, 100%. So we're going to put them equal to each other. Sine of x plus 30, sorry, I didn't realize you had the microphone still, that's wonderful, is cos of 2x. Now, there are 2 types of trig equations with sine and cos. The easier one would be one like this. Sine of 2x equals cos of 2x. Who can tell me, what would I do with that? Sorry. I would, yeah. That's absolutely right. If I have sine and cos of the same angle, I can divide by cos and I can make tan. Cordwa, this one, the angle is not the same. Okay? The angle is not the same. So what can I do now?
So say cos
Yeah.
minus open bracket x plus
Well done. This cos 2x. So guys, what's your name? Elisha. What Elisha has done is he's changed this sine into cos using co-ratios. He could also have changed the cos, sorry, he's changed the sine into cos using co-ratios. He could have changed the cos into sine. Okay, Elisha, what you've got in your brackets now is 60 minus x. Okay, and over here we've got cos of 2x. Now this is where it gets slightly interesting. Okay, tell me what next.
So cos is and
Well done. Yes.
is equal to 2x
Yeah.
minus 3.
Yeah. Or, okay, so that's fine. Yeah, we just in quadrant 1. Yeah.
minus 2x on both sides.
Yeah.
With and then I add subtract 60 on both sides.
Well done.
Then I divide by 3, negative 3, so means yeah.
Okay, it's 20 plus or minus, doesn't really matter. It's actually minus, but 120k. Okay, cool. That is a solution set for quadrant 1. How are we going to do the solution set for quadrant 2? Quadrant 4.
Quadrant 4 is 60 minus 6
Yeah.
equal to 360 minus 2x plus 260.
Okay. And so this one, I'm going to go a little bit quicker here. I'm just going to, we're going to add 2x to both sides. We're going to get x. We're going to subtract 60. We're going to get 300 plus 360k. Okay, and this is the quadrant 4 case. This is the quadrant 1 case. Okay, and so now let's generate. We only want answers between 0 and 360. Let's write them in red. 20. Definitely an answer. All right. If k is negative 1. Guys, if k is negative 1, we're going to add 120. 140. If k is negative 2, we're going to add another 120. 260. If k is negative 3, we're going to add another 120, but we're going to go outside. Okay. And then this one, the only option is if k is 0, we get 300 degrees. All right, and there we have it. Okay, now guys, if I look at the question, it asks for the points of intersection. I'm not going to do that to save time, but guys, look at this. This is 20. This here is 140. This one here is 260. And this one here is 300. Elisha, I think next time maybe you must come and run the session up at the front here. Well done. Right, that for me, that's one of the harder things in your matric syllabus. Okay, very, very well answered, beautifully answered. All right, guys, we're not going to do everything here, so I'm going to just look at a couple of things. Let's look at this, and we're not going to solve this whole question, but what on earth is this, guys? You can quickly tell us, what is that? It's cos of what? It's cos of? Well done. It's a compound angle formula, guys. You need to learn these things. You need to learn them in order that you can recognize it. Now, I'm very quickly going to talk you through how I like to solve this, okay? I like to find what I call a key angle, okay? The key angle and the key to finding the key is to undo the ratio called where we don't put in the negative value. So I'm not finding the answer. I'm finding a first quadrant angle that gives me the right size. Okay,
Goodbye,
in this
sir.
case,
Goodbye.
I
I'm
happen to know-
leaving.
I happen to know that that's 30 degrees. Okay, now, which quadrants do I want to be in if cos is negative? Which quadrants?
Goodbye.
1, 2, 3, or
Goodbye.
4?
Goodbye. Goodbye.
Where's quadrant cos negative? 2 and 3. Now what I do is I use my key angle. So I'm going to go 180 minus my key to get into quadrant 2. I only use the horizontal axis. Normal, I can go 180 plus my key to get into quadrant 3. For both of these, I can add 360k as often as I like. Okay, and the last thing, the very last thing, I'm saying to myself, this is not theta. This is actually 2 theta minus 10. So 2 theta minus 10, that, or 2 theta minus 10 is that. Okay, and I'm not going to finish this question because from here it's algebra. I'm just going to add 10 to both sides on both equations, and then I'm going to divide everything through by 2. Don't forget, whenever we write a plus k, we should say k is an integer. Okay. All right. I am looking at what sorts of questions we should try and do next. Okay. And I'm going to ask you to try number 5 and 5A and 5B. And I'm going to give you 5 minutes just to look at them. All right. And while you're looking at them, I'm just going to be talking to your teachers. So maybe you can just ignore that and carry on. Try 5A and 5B. Okay. So for the teachers, for each of the schools here, there are 3 different documents that we want you to take with you. Okay, there's just 1 or 2 exceptions to that, but for most cases, the Bulamati is only in order. Okay, because you don't have grade 8. Okay, but the powerful documents here, there are 3 things. Okay, in fact, there are 4 things. There's a register for a grade 8 revision session. What we want you to do, if you can't do it in your school's online next Saturday, I'm going to be online, that's great. Even if you get the document to the learners, you can show it, we will record that. So however you manage that, then there are 2 tests. There's a grade 8 test and there's a grade 12 test. And we're just going to send you the digital copies of the solutions for those. So when you leave today, and some of you, unfortunately, some of you, the big schools like Nizaneni, this is the box from Nizaneni grade 8, 300 and something of them, okay? But most of it's not bad boxes, okay? And they're in alphabetical order here. So Amat will be, Asituke, Dabula Manzi, Lungro, and Nizaneni, Njogoba, Jabula, Sizabule, Stelfana, Yasumula, and Tendela. Okay. All right. I think I said you might be here without a teacher, in which case the learners must take those envelopes and get them to the teacher. We're hoping that you'll write that test at school. Okay. All right. Now, this one here, guys, 5A, I think is quite difficult because I don't know a formula for sine of 3x. Can anybody suggest something that we can do here? Maybe we don't need a formula for, yeah, okay, great. Okay, so you can do that, yeah, okay.
Plus 8. Then introduce a compound input.
Okay.
It's going to be sine 2x.
Yeah.
Sine 2x cos x.
Yeah.
Plus cos 2x sine x. Plus sine x.
Okay, I'm going to stop you. Okay, I'm going to stop you because I think you might be able to. I'm sure you can get there. Okay, but I'm going to show you that it can be done quite a bit more easily. Okay, I'm going to ask you, and maybe you want to keep the microphone. I'm going to ask you just to add these 2 fractions as they are. Yes.
Plus cos x. Or x sine x. Or over sine x cos x.
Well done. Okay, you're my friend. You are very, very sharp, right? Because you managed to. You are very clever, right? You managed to completely deal with the fact that I totally changed your direction, and you picked up on it and you added those fractions beautifully. So well done. Yeah, okay. Now, do you recognize this top piece as anything? It's a compound angle formula. Which one is it? It's sine of?
X plus X.
Well done. It's 3x plus x. Okay. Now, on the bottom, we've got sine x cos x. Okay. What does sine x cos x sort of remind us of? Well done. It sort of reminds us of the double angle sine. Okay. All right. On the top, we've got sine 4x. Okay. On the bottom, we've actually got half of sine of 2x. Am I right? You're going to multiply by 2 over 2. That's a cool thing to do. Okay, that's a very cool thing to do. Okay, so what he suggested is he's going to multiply. So what's your name? Just said, or maybe Asada. Sorry, Asada. Thank you. Okay, so you're saying we've got 2 sine 4x over 2 sine x cos x. Well done. I like that. It's a good way of explaining it. Now what? What have we got on the denominator now? Well done, sine 2x. And what can I do about this 4x? Can I do a double angle? I can make this 2x, yeah. Okay, and now let's use our sine formula just for this stuff. Sine of 2 things. Sine of 2 calculators. 2 sine calculator, cos calculator. So what will this be inside here? It will be 2 This is the angle here, this 2x. 2 sine 2x.
That's why, because again, the way
No, I appreciate that. You've actually, I've asked you to try and do it not the way that you would have preferred to do it. Okay, but are you okay that sine of 2 lots of 2x is actually 2 sine 2x cos 2x? Because if you are okay, then we're done, aren't we? Yes? Aren't we done now? Because the sine 2x's can divide out, can't they? And then I've got 2 and 2, I've got 4 cos 2x, which is my right-hand side. Okay, all right. The way you were going to do it works. It's just a bit longer. Okay, all right. Now, we're going to do, we're going to ask someone to help us with B. Okay, we've got a few hands up, which is really encouraging. I think, yeah, give a couple of sweets to us under there, Ruth. Yeah, because that was a very good effort. Okay, yes, right, so B. Guys, notice I'm working always with the left-hand side and the right-hand side separately. You're not sure and you want to give it to someone else, that's fine. Yes, okay.
I'm gonna change the cos to theta
Okay, to what?
to 2 cos squared theta minus 1.
Okay, I want to just pause you there. It's an excellent choice. Why did you choose that one and not cos squared minus sine squared norma 1 minus 2 sine squared? Why did you choose that one? Do you know? 100%. Hala. Guys, listen to that. He chose that one because he didn't like having this plus 1 here. This is the only one of the three that's got a minus 1 in it. Okay, so what have you got now on the denominator? Okay, and we can divide those out. And final answer, it's tan squared theta. Okay, you might want to, guys, you might want to write it like this because this is an exponent idea. If you have a fraction with a power on, which one gets the power? The top or the bottom or both? Both. Okay. And guys, what's sine over cos? It's tan. So tan squared theta equals right hand side. You can definitely go straight from here to here as well. Okay. Well done. Very, very well done. Okay. Right, guys, I'm not going to do this graph drawing. It's a little bit fiddly. I'm also not going to do the finding of equations. And I'm, in fact, not going to do that either. We're going to move into solution of triangles. We've only got about 10 minutes left, all right? And I want us to look at this question here, question number 5. I'm going to give you 2 minutes just to look at this question initially, okay? The question asks us to find the area of this triangle. This is an unusual question. This is a problem-solving question. I don't want to make you scared. It's a problem-solving question. Ruth, just wondering if there's any sound of Elton and my backing. Did you want to just go out this door?
Term 2 syllabus.
Oh, is it? Oh, sorry. Thank you, guys. Apparently, this stuff is in your term 2 syllabus, which I did not know. Okay, but graphs is definitely in this term. All right. So, guys, I'm not going to draw these graphs. They're quite fiddly to draw them. So, right now, I'm not going to draw them because we have drawn a couple. Let's look at question 7. And question 7 is finding equations. No, Solomon. Okay, do you want to find him? Yeah, his name's Elton. Wow. I'm next to it.
And the question next to you about is now what?
Okay, right, guys. So let's ask ourselves, what sort of graph might this be? I think it's a sine graph. It seems to have been reflected about the x-axis. Okay. There's actually probably too many things going on here for an exam question because we normally will only allow 2 things. There's actually 3 things that have happened here. Would anyone like to try and tell me the final answer for this question? And there's quite a lot going on here. All right. Anybody, I don't know if, I think Ruth might have the microphone. I don't know if I just got it. Yeah, put your hand up if you think you might know. And it doesn't matter if you get it half right. That's fine. Okay, people are suggesting sine, and I'm liking sine. Okay, right. I'm going to highlight a few things here. All right, I'm going to highlight that, and then I'm also going to sort of say to myself, 1, 2. Three. All right. Anybody want to have a go? Yes.
Sine x minus 45.
I don't think it's going to be sine of x actually, because there are three graphs here. And I also don't think this graph has moved left and right. Okay, not a problem. I'm wanting anyone else, anybody else who's got an answer. I'm going to say that again. There are three graphs. Okay, I'm also going to, we've already spoken about the fact that we seem to have the thing reflected. In other words, maybe it would be easier if it was going like that. Okay, and then the last thing that I've highlighted here as well is it's going up to 2 and down to minus 2. Okay, yeah. Okay, I'm seeing a hand here. There we go.
I think it's going to be 2 sine x.
Okay, two sine x is not bad. I would give you a mark. All right, but if it was 2 sine x, I'll show you what 2 sine x looks like. I'm going to draw 2 sine x for you. That's what 2 sine x. What's it? Okay, well, that's better than an accident by some measure. Okay, all right, guys. So the 2, I'm liking the 2. Cordwa, there are 3 graphs here. How am I going to get 3 graphs? I need 3x, guys. 3x is going to give me 3 times more graphs than usual. Okay, and then the last, this is still not the right answer because it's reflected. How do I reflect a graph about the y-axis? I put a negative there or there. All right, guys, that's quite a hard one, okay? And to be honest, there's too many things that are being asked in that question. But for me, that question would be out of 4 marks maybe. 1 for getting that it's a sine graph. 1 for, okay, so here's where I would give the 4 marks. 1 for that, 1 for that, 1 for that, and 1 for that. Okay, all right. Now, I'm interested in who can help me with this one. Okay, and again, maybe this one's got 3 marks. Okay, you need to pick the right sort of function first. Then you need to tell me, yeah. Put your hand up if you think you know.
Sir, I think it's called x minus 2.
Cos x minus 2. Okay, so I think you're very close. I don't think you're quite there. Okay, cos x minus 2. And the reason I don't think you're quite there is because the amplitude has changed. Eh? Let's look at how tall this graph is. How tall is it altogether? It's actually 4, isn't it? Yeah, so the amplitude is 2, half of the total height. So now you're saying 2 cos x maybe. But then if it's 2 cos x, maybe you want to just rethink minus 1. Well done. Halala. Guys, it's 2 cos, yeah, definitely a clap. It's definitely, right, now guys, a little hint. A little hint. I know, so my computer's on the fritz now, which is not great. Okay, it's just doing its own thing. But guys, we know that this graph has moved vertically because the x-axis is not going through the middle. There's less graph above than there is below. Look at this one. The x-axis is going right through the middle. This one also, the x-axis is going through the middle. Okay, so the graph has moved down. I would give 3 marks for this question. There, there, and there. All right, I'm looking for someone to help me with the next one. And I'm going to tell you that there are 2 possible answers for the next one. You might be able to give me an answer involving cos. Norma, you might be able to give me an answer involving sine. I'm going to ask someone if they can tell me, what is this graph? What's actually happening here?
Exalum. Break. We need break. We need break.
Okay.
Ano lang?
All right.
We need
Guys,
break.
let's look at the period. Has the period changed?
Break is required.
I don't think the period's changed. Okay. So in other words, after 360 degrees, it's done one full wave.
We need break.
Break is required.
Has the amplitude changed?
Sir,
Yes.
could it be called x minus 30 degrees?
Okay, so we've got an offer for cos of x minus 30. You are 100% correct, okay? If the cos graph has, I think, hang on, wait, I'm saying that with great confidence. Yes, the cos graph moved 30 degrees to the right, guys. This is 30 degrees here. And normally the cos graph would be on the origin, it would be at 1, at 0. Now it's at 1 at 30. A cos graph 30 degrees to the right. Can someone tell me, if this was a sine graph, how much would it have been moved?
Break.
Which way has it moved if it was a sine graph? And how much has it moved, guys? This, I will tell you, is minus 60. So how much has it moved? 60 degrees to the left. How do we move a sine graph 60 degrees to the left? Plus 60. Right. Okay. This is a sine graph moved 60 degrees to the left. Okay, normally sine is, so here's 120. I'm just checking ourselves here. If you put 120 into here, you get 180, and sine of 180 is 0. Okay. Likewise, normally cos of 90 is 0. If you put 120 into here, you get cos of 90, you get 0. Okay. Right. The last one of these that we're going to do. All right. What's this one going to do? What sort of graph is this? Sine. Tan. Oh, tan. Okay. It's a tan graph. Do you want to tell me what you think the equation is? The guys that are online, if you wouldn't mind just muting yourself, because there seems to be quite a lot of noise at this stage. So I'm just going to mute people. Okay. All right. So that's great. All right. Yes. Well done. It'll be y equals tan of a half x. Okay. We can also write that as y equals tan x over 2. Guys, we've got half as many tan graphs as usual. The only thing we do need to check, all right, and we're going to need to check this. I don't think this is the final answer, actually, because we just need to check. Normally, a really important point on a tan graph is that when we've got 45 degrees, our y value must be at 1. Now, if we look, when we put 90 into here, tan of a half of 90 is tan of 45. If nothing else has happened, then it should be at 1. And it's not at 1, guys. It looks like it's at a half. I actually think the equation to this one is a half tan a half x, or a half tan x over 2. Same thing, just written in a different way. Okay. All right. So, okay. Let's look now at question 8. I'm going to give you just a minute or two to try it.
The glasses, the 48 people who produces a lot and work with a lot. Yeah. It's too like, you know, how many managers now. I'm just going to part of that and I'm just going to straight to the back, straight up. Yeah.
So, Ayada, Victor Messize. Thanks. So, yeah, I think for now, just open. Typical, yeah, it would be great if you just video them giving them a lunch. I say leave it again.
Yeah, it's going to be fairly chaotic. Okay, so we've got burgers coming in, we've got juices and chips. Just but the juices need to be unwrapped, so it'll just start helping me. I just think yeah, just leave the microphone.
Okay, right, guys. So let's just try this question and then we'll have a look. So here we've been given the basic format of these formulas. So this one is a sine graph. This graph over here is a sine graph, but they're asking about maybe a change in the amplitude and a possible change in the period. And then this one over here is a cos graph, okay, but it's been shifted a bit. Okay, so let's see if we can work out what are the values of A and B first. Let's just look at this graph. We're talking about this graph over here, this blue graph. It's a sine graph. Okay, has the amplitude changed? Guys, has the amplitude of this graph changed? No. So what will A be? A is 1. This is a perfectly normal height for a sine graph. A equals 1. Has the period changed? Yes. What's the period of this graph? It's 180. So how many graphs would I get between 0 and 360? I would get 2. And so what is B? B is 2. Okay, so A is 1, B is 2. Now we're looking at this graph over here, this yellow one. Okay, and we're told that it's just a regular cos graph, but it has shifted to the left. Okay, and the question is, how much has it shifted to the left? Now, guys, these little angles, we're going to have to work out how many of these there are. 1, 2, 3, 4, 5, 6, 7, 8, 9. So each of them is 10 degrees. So this is actually minus 20 degrees. So how has this graph shifted? 20 degrees which way? To the left. Must C be positive 20 or negative 20? Well done. Guys, what I'm hoping you are starting to understand. Although we're doing trigonometry now, this exact same, the exact same concepts and principles occur in our algebra. Okay. Right, now we ask for some questions. What's the period of the blue graph? We've actually already said that. What is it? 180 degrees. Okay. What's the amplitude of the blue graph? 1. Guys, just careful. Often people think the amplitude is the total height. It's half the total height. Okay, it's 1. And then it says, determine the x values of the points of intersection where these graphs cross over. Okay, so it's there and it's, okay, right. This could be interesting. So we've got cos of theta plus 20 and we've got sine of 2 theta. To find where they intersect, we're going to put them equal to one another. Cos of theta plus 20 is sine of 2 theta. All right, now, what technique are we going to use here? And I think it was Alicia who did it for us before. What are we going to do? Co-ratios. Well done. We're going to go with co-ratios. Okay. So one of these we need to change into the co-ratio. Last time we changed the sines into cos. All right. This time maybe we can change the cos into sine. But it actually doesn't matter which one we do. Okay. All right, guys, I'm just checking on my sister, seeing what she's doing. All right, because we basically are, yeah, in fact, we'll quickly do this question. Okay, I'm going to just quickly write the answer down to this question, okay? So I'm going to leave this as it is. I'm going to change this one to the co-ratio. Okay, and now there's two cases. Either they are equal, all right? So theta plus 20 is 90 minus 2 theta plus 360k, or theta plus 20 is 90 minus 2 theta, sorry, is sorry guys. Okay, my computer's trying to catch up with all my undoing. Okay, and I hope it doesn't undo everything. This one will be 360 minus 90 minus 2 theta plus 360k. Okay, I'm going to do this quite quickly in my head. We're going to add 2 theta to both sides, and we're going to subtract 20, and then we're going to divide the tract through by 3. So theta is going to be 70 over 3 plus 120k. And this one, we've actually got negative 2 theta. So we've got 2 theta, so this becomes negative theta. So we divide through by minus 1. All right, and here we've got 270, we've got 250, so it's going to be negative 250 plus 360k, or minus 360k, it doesn't matter which. Technically it's minus. Okay, guys, we're going to stop there, all right? And I'm going to stop sharing and I'm going to leave the meeting that I'm in.